Practitioner exam. Feel free to obviously message me on the chat, and obviously there will be certain points during the actual training where I will look at some of your questions in the chat. This session is being live streamed as well on YouTube, so you can take a look at the recording there later on. So we'll get started. Essentially, the way how it is the 4-hour breakdown is going to be where we cover the core set of topics and all of the key materials that you need to learn in order to prepare for the exam. So this is a revision course. So obviously what that means is that I'm going to be going through all of the core topics that you need to learn to prepare for the exam, but at a revision level. Okay, so it is anticipated and assumed that obviously you are already taking the course or you are studying for the exam, and now you've come to actually take a revision course in order to prepare for the actual exam. By the time we end the course, we will also be looking at some practice exam questions, where I will give you a demonstration as to how you can answer those practice exam questions, and then we will go ahead and then call it the end of the session post that. Okay, so I'm going to be whizzing through a lot of core contents, but we will be taking regular breaks so that you can grab some tea, coffee, or just if you need a quick short break. So we will be taking that into account as well. Okay, so we'll get started in the next 1 minute. Just bear with me. Okay, can I just confirm that everyone can see the screen?
Yes, it's visible.
Yeah, fantastic. Perfect. Thank you. Okay, well, welcome to the Cloud Practitioner course, the revision course. As I mentioned earlier, this is a 4-hour training program. This is designed to help you prepare for the exam, and it assumes that you've already started studying for the Cloud Practitioner exam. And it's one where we're going to go through the wide range of topics that you need to know in order to prepare for the exam. And by the end of this training program, it is anticipated and hoped that you have a lot more understanding about what the exam looks like, but more importantly, that you understand all of the core topics in a lot more detail. Now, we are going to deep dive onto some of the topics because I feel that a lot of the topics, across all of the topics, there are some topics that are heavily tested on the exam. Okay, so we're going to deep dive into some of those topics as well. But mostly we're going to be covering the core concepts, the core points that you need to understand in order to successfully answer those questions in the exam. So we'll probably start off by taking a look at the exam details and the exam syllabus. And so if you take a look at the actual Cloud Practitioner exam guide, this is available to you from the AWS website. And essentially, it is a 65-question exam. Okay, it's based around multi-choice and multi-answer question formats. To be honest, the questions are fairly simple and straightforward at the foundation level, but it is anticipated that obviously you have the breadth and the depth of knowledge across all of the core topics, the various services that AWS provides in order to successfully pass the exam. Okay, so do have a read of the actual exam guide. You need to score 700 out of 1,000 points in order to pass the exam. There are 65 questions on the exam, and it's 130 minutes. So basically what that means is just over a couple of minutes per, sorry, it's a 90-minute, so it's just over a minute a question. And so you need to actually be really fast on this. The core domains covered are cloud concepts. That looks at things like cloud value proposition, covering things like what is cloud, what are the way how cloud is designed and built in terms of cloud deployment models, cloud usage models, and then taking a look at some core concepts around things like well-architected framework, shared responsibility models, and what those things mean in the cloud. You also need to understand and remember things like the 6 advantages of using cloud computing versus on-premises environments, and so on. Then you also have an expectation to understand cloud adoption strategies. This is more related for the business to see when a business is deciding to make a digital transformation into the cloud. We want to see exactly how the business performs and actually does all of the things that it needs to do. So what are the stages that a business needs to follow in order to join and become a cloud native organization? So what are the steps that it should follow in its cloud adoption journey? And there's a whole section on the cloud adoption framework that you must learn for the exam. So it's a series of business perspectives and capabilities that an organization must have in order to successfully transform into the cloud. So I'll share a link for that for you as well. There is some elements around cloud economics. So we cover things like billing and pricing models that you need to be aware of, how to ensure that you are being cost effective when using cloud computing. So we'll cover some of those topics. There's a huge section on security and compliance. Compliance and security is a really important part of the exam. You're tested on the shared responsibility model. You're tested on things like how to ensure that you're cost effective. We're going to cover things like the AWS S3 storage classes and how you can use the storage classes to actually define, how effective you are in the pricing sense. So depending on how your storage needs are, you can choose a specific storage class to ensure that you're cost effective. Things like EC2, when we took a look at compute services, there are different pricing models for EC2. So depending on your use case, you can be more cost effective. And those are things that you need to know at the cloud practitioner level. You're also expected to get involved and understand various security tools. So we'll talk about Macie, GuardDuty, Shield, WAF, what those tools are and what they do. Identity and access management is a really important part of the exam. So things like understanding the use and role of IAM users versus IAM roles, they play a really important part in the exam. You also are expected to understand what, after all, is the principle of least privilege, which IAM tool to use to manage your identities, whether it's cross account access or whether it's workforce identities, and so on. You also need to learn about various other cloud technologies. So we'll take a look at things like how you deploy cloud services, the cloud global infrastructure for AWS, regions and availability zones, what they are, what they mean. And then also we'll take a look at things like the various technologies. So you've got compute, containers, Lambda, database services on AWS. So things like Amazon RDS, Aurora, NoSQL DB, which is DynamoDB. So you need to know their use cases and where you would use those services and the key differences between those database tools. If you're migrating database from on-premise to the cloud, what tools are available for that? That's another important exam-related topic. We'll go into networking a little bit. We'll take a look at networking in the cloud, how you need to build a corporate network in the cloud. And also we'll be taking a look at storage services that are available as well. We'll cover a little bit on machine learning. There are some machine learning topics that you need to know for the exam. Okay, so some basic high-level understanding of different machine learning services. And then a few other services that are still in scope, but are spread across different categories. So things like EventBridge, integration services like SNS, SQS. We'll take a look at things like workspaces, Kinesis for analytics, and so on. So this is an important document to really keep with you so that you ensure that you are able to go through it and actually make sure that you study all of these key topics. Right. We will be, obviously, this is being also streamed onto YouTube, so it will be available to you post-session as well after the recording. Okay, so let's go ahead and actually get started. So we'll start off very simply, covering the basic concepts around cloud computing and AWS basics. And one of the key topics that you're going to see in the exam is a question around things like, what are the different cloud computing models? So you need to know the key differences between SaaS, PaaS, and IaaS, infrastructure as a service. And at a very high level, basically what it is infrastructure as a service gives you access to core infrastructure services, which means that you can build from the ground up all of the necessary infrastructure, albeit a virtual infrastructure, to support your application. So things like servers, okay? If you're deploying EC2 instances running Linux or Windows servers, that's an infrastructure as a service product, okay? Because you get from the operating system level up, you have full control and access into how you design and configure that service. VPCs are an infrastructure as a service tool. You have to design a VPC, you have to build a network within which you can place all of your core EC2 instances. Or your databases or Lambda functions or any kind of connectivity into any of the public services that AWS offers, like S3 or DynamoDB. So VPCs are another infrastructure as a service product. Platform as a service is where you essentially focus on your application code. You deploy your application code to AWS, and AWS provisions that infrastructure for you. So it provisions the EC2 instances. It creates the databases. It creates the underlying network for you. Platform as a service tool makes it a lot easier for developers to start working with the AWS cloud rather than worrying too much about how to configure the infrastructure in its minute detail. So core service on AWS that offers PaaS services is Elastic Beanstalk. And then you have a number of SaaS-based services as well. So for instance, you have tools like SES, Simple Email Service. So Simple Email Service is a mail messaging system that allows companies to use mass mail campaigns, for instance, as a use case, so they can send out advertising or marketing campaigns using the SES service, and it's provided to you as a SaaS-based product. So AWS offers a whole range of different services that spread across these three categories, and understanding the key difference between IaaS, PaaS, and SaaS is also critical for the exam. Also, when it comes to deployment models, you want to understand the key differences between public cloud, private cloud, and hybrid cloud. And in a very high-level nutshell, public cloud is what AWS offers you. It's available to various customers. It's available to the public. Private cloud is where you're building your own infrastructure and then using software to manage that infrastructure. Cloud software, if you will, and how you provision resources and how you allocate resources to different departments in your organization. But it's all done private within your own private data center or co-location or whatever that might be. And then hybrid cloud is a means of connecting your on-premises private cloud with the public cloud and having a hybrid solution. Most organizations today are in some form of hybrid cloud deployment because they'll have some on-premise services and they will have public services as well. So the 6 advantages of cloud computing, this is one that's recommended and basically promoted by AWS. So AWS gives you these 6 advantages of cloud computing, and you're likely to see an exam question that tests your knowledge on this. So I would bookmark this particular screen, if you will. So the first one is trading fixed expenses for variable expenses. And what that basically means is that you are trading your fixed costs where you have to buy expensive hardware, pay for real estate to host all of that hardware, all of the servers, databases, networking equipment, firewalls, all that hardware equipment. Instead of doing all of that, you can just go on a pay-as-you-go model, pay AWS on a pay-per-consumption basis, and therefore your fixed costs, or what would have been a fixed cost, have now transformed into variable cost. Depending on your consumption levels, depending on your usage levels, your costs can actually come down. With fixed costs, whether you're using the services or not, you're still going to pay for it. With variable costs, you have control over how much of the services you're going to consume, and you get charged accordingly. You benefit from massive economies of scale. This basically applies because AWS has thousands, millions of customers, and so they're able to cut down the cost of those individual services so that they're affordable from startups all the way up to large corporate organizations. If you were going to build your own machine learning AI training model, for instance, you would be spending a lot of dollars on expensive hardware. Instead of doing that, you can use AWS's tools and services and you'll find that it's a lot more cheaper in the long run, obviously depending on your usage patterns, but ultimately you benefit from that massive economies of scale. You can stop guessing capacity. So back in the day, we used to over-provision resources. We would buy extra servers or extra networking equipment, extra hard disks, just in case there's a failed component. You don't need to do that anymore. You can use auto-scaling services to automatically scale out your resources or scale back in, depending on the demand that is coming in, requiring those resources. You have increased speed and agility because you have access to all of the APIs to provision those resources within seconds to minutes. And you can quickly provision resources with the help of AWS services. And you don't have to spend money on running and maintaining expensive data centers, because data centers are not just the equipment you provision, they're also the cost of heating, cooling, electricity, physical protection in terms of security guards and all of that stuff. There's a lot of cost, hidden cost associated with running and maintaining your own data centers. And you can go global in minutes. So with AWS, you have access to all of these different regions across the globe. And what that basically means is that you could provision your resources in the US if you're a US company, but you can provision a data center or a disaster recovery center in Sydney, Australia. Okay, you don't need to physically be in Australia to provision your resources there. So this becomes really easy for small companies as well as large organizations that want to have a global customer base. So these are the 6 advantages of cloud computing that you really must learn and understand. You're likely to see real-world exam questions when you enter the exam room on them. The AWS Help Dashboard, when you create your AWS account and you run all of your resources, is something that you want to keep an eye on. So the AWS Help Dashboard allows you to monitor the health of any of your resources, in the sense that if AWS is making any planned changes or maintenance work or anything like that, then if any of those changes or any of their work is going to affect your resources, that will be listed in the AWS Help Dashboard. So you can see if any schedule changes that they're planning, for instance, maybe they are upgrading some of their servers and one of your VMs, one of your EC2 instances are running on that server, you will see a notification of that and you can take appropriate action, or they will tell you what needs to happen in order to ensure that you don't experience any outage. So that's the AWS Help Dashboard. You'll likely see an exam question on that as well. Okay. The AWS Artifact is another service that you can use. The AWS Artifact is designed to help you provide you with information and a lot of resources around things like agreements, reports, things that are related to compliance, laws and regulations. And you can access the AWS Artifact service to get access to all of these different reports. So we've got the compliance report for Amazon Cognito user pool. This gives you all of the certifications and attestations with regards to that particular product. And so for all of the different products and services, you actually can see fine-grained details, all of the NDAs, all of the agreements that AWS has in place, so that you may be able to provide that information to your organization, maybe your auditors that need to see those pieces of information and see how compliant you are as an organization. The one thing you have to remember is that AWS will obviously offer a lot of certifications and attestations to various rules, laws, regulatory requirements. So GDPR, for instance, or HIPAA, or PCI DCS compliance for credit card processing. That is at the AWS level. That is at the infrastructure level, at the services level. But when you're building your applications to host them onto AWS, you too must follow certain guidelines and principles. So you need to be aligned with those requirements. If you are in the US, for example, and you run a healthcare organization, you need to make sure that the way how your application is built conforms to any requirements or regulatory laws as per those compliance laws, like the HIPAA laws, for instance. So this is where that shared responsibility model comes in. AWS shares responsibility with you in order to provide those services. And we'll talk about the shared responsibility model again. But just remember for the exam that there is a tool called the AWS Artifact service that allows you to access all of the agreements, all of the reports for these various attestations, certifications that show how they meet those compliance and regulatory requirements. And again, AWS offers a whole range of different compliance offerings. So PCI, HIPAA, FedRAMP, FIPS 140, etc. And you can see all of these different compliance laws and frameworks that AWS has in place as well. So just remember, for the exam, there's the AWS artifact, there's the AWS compliance service. Trusted advisor. When you're using AWS and you're building your solutions, one of the tools that you will find very useful is the AWS Trusted Advisor service. So the AWS Trusted Advisor service is a service that monitors and looks at all of your different resources that you've provisioned, how you've provisioned them, how you've configured them across a set of categories. The categories are cost optimization, performance, security, fault tolerance, service limits, and operation excellence. And what this means is basically, so here we're looking at the security side of things. Okay, so we've clicked on the security category, and in this screenshot, we're saying that the MFA on the root account has not been enabled for this account. Okay, so it's marked with the red X. So you get a traffic light system, red for something that is something you really need to do about, amber, or the exclamation mark, which is a warning sign, and then you get a green tick. Your aim as a solutions architect or as someone who's managing the cloud services for your organization is to make sure you get all greens. And so at the same time, there may be one or two, exclamation ambers that you are fine with, you're okay about because they fit your specific business use case. But you definitely want to avoid all of the reds. So you should enable MFA on the root account, for example, and that should turn to green then. Because this account hasn't had MFA enabled, AWS is giving you a heads up to basically say, hey, listen, MFA is not available on the root account. You should be doing this. So the Trusted Advisor service is a set of guidelines, a way of AWS telling you how your account has been provisioned and where you need to make some remediation and changes. So this is for security, but obviously there is a category on performance. There's a category on cost optimization. If you're running some load balancers that are not being used, load balancer is a chargeable service. If they're not being used, AWS will highlight them and say that, hey, listen, you're not really getting any traffic to these load balancers. Are you sure you don't want to terminate them? So that kind of thing. And so the Trusted Advisor is a really excellent tool that AWS uses or gives you to basically analyze your environment and to see where you can make changes to improve, to be more cost effective, to improve performance, to ensure security, to implement fault tolerance, to make sure that you're not crossing any service limits, and to ensure that you're operating as excellent as possible. Okay, now the AWS support plans is the next thing that I want to quickly talk to you about. So the AWS support plan is something you're going to see in the exam. You're going to get tested maybe 1, 2, 3 questions, and it's going to ask you, it's going to be framed in the form of a scenario, which is going to say, okay, I need to make sure that if I have a severe outage on one of my production servers, I have a response time within a matter of minutes. Well, in that case, you're going to need the enterprise support plan. Okay, so sorry, just come out of there. You're going to need the enterprise support plan. You've got 5 different plans. You've got the basic plan, the developer plan, business, enterprise on ramp, and enterprise plan. And so what you need to be careful about is which plan you select is going to depend on your specific business use case. So if you get a question that says you're building an application or you're developing an application in its early stages, it's just being tested or it's just being developed. So it's not production. It's not a business critical application. Well, then you might get away with being on the developer plan for that specific AWS account. Okay. Now the developer plan gives you technical support only during business hours, right? But if you want 24/7 telephone support, then you need to be on a minimum of the business support plan. Okay, so depending on what your requirement are as an organization, whether you've got production workloads, enterprise workloads, if you need a technical account manager, or rather a dedicated technical account manager, then you have to be on the enterprise plan. And depending on which plan you choose, the cost obviously increases. The other thing to be aware of is that with these support plans, the Trusted Advisor service comes as part of the package. So the Trusted Advisor service gives you fairly limited information if you're on the basic and developer plan. If you want the full set of checks, the performance, the fault tolerance, the security, and all of that stuff, you need to be on the business plan at the very least. Yeah, okay. And likewise, if you need like a dedicated technical account manager, then you must be on the enterprise plan. But I would highly recommend that you visit the website. So that's the AWS Support Plans website, and really study this document or this one-page web page really well, because you're likely to see 2 or 3 questions on the exam just on this alone. Okay, let's talk about the shared responsibility model. So the shared responsibility model is, again, another typical scenario question you're going to get on the exam. And what you need to remember about the shared responsibility model is that anything you put in the cloud, the responsibility or the security of that resource that you put in the cloud is shared between you and AWS. AWS looks after the infrastructure, the underlying network, the underlying hardware that supports, say, for instance, a virtual server, an EC2 instance that you deploy. But you're responsible for patching that server. It's an EC2 instance running a Windows operating system. You're responsible for, what antivirus software you install on it. You're responsible for whether you're patching it on a regular basis. You're responsible for what ports you open on it, and so on. And so it's important for you to understand where your responsibility comes in. And the best way I like to look at it is, if I can configure it, if I can make configuration changes to it, then I'm responsible for it as a customer. So if you as a customer can go into AWS and create a VPC and set up some subnets and configure a route table and deploy a security group, well, then that means you can configure it, and therefore you're responsible for how you configure it. So when you see a question in the exam that refers to the shared responsibility model, is it your responsibility as a customer or is it AWS's responsibility? You need to ask yourself, can I configure it? Can I actually make configuration changes to it? If so, then it's the customer's responsibility. If I cannot touch it, so I cannot actually configure the hypervisors, I cannot configure the network cables, I cannot configure the underlying firewalls that are running the system, then it's AWS's responsibility. And that's really critical. Most of the managed services, the level of customer responsibility reduces. So things like RDS, where the backup takes place, is not your responsibility, but configuring backup is your responsibility. Enabling backup is your responsibility. So you got to see how that works. If you can configure it, you're responsible for it. Okay, so let's take a look at how you access AWS. Well, you can access it via the web console, using CLI, using the CloudTrail tool, or programmatically with your application, using the software development kits for various languages, so Python, Java, whatever it might be. Okay, so there are different ways of accessing AWS. And I'll quickly bring up the next slide deck. So that covers our basic introduction to cloud computing. Let's move on and talk about a key topic that you're likely to see in the exam, which is identity and access management. Okay. Okay, so we'll go on and talk about identity and access management next. So the root user account Who's the root user account? Well, the root user account is the person that created the AWS account. So when you create your AWS account, you will be using a username and password, or rather an email address and password. And that email address and password is going to actually be the one that's the owner of the account and the root user of the account. And you can access the AWS account using the web console or the command line interface, and it gives you access to all of the different regions within the retail AWS space. So AWS has several different partitions. The retail partition, as I like to call it, is one that's available to standard, normal, commercial, or private customers. It's got other partitions for the US Gov, for China, etc. But the partition that you work in gives you access to a whole host of different regions, and within those regions, availability zones across the globe, covering the Americas, Europe, Africa, Australia, etc. But the root user has full access to the AWS account, and it can create and delete resources across all of the different AWS services on the AWS platform in every region. So the root user is all powerful. And so as a best practice, you want to make sure that the root user account is protected. You should not be using the root user for day-to-day operations. Okay, you should use the root user only for some specific tasks to set up the account, and as an ultimate last point of escalation if something goes horribly wrong with your AWS account. There are certain actions that only the root user can perform, like changing AWS account settings or restoring IAM user permissions if an administrator account has locked themselves out. Closing the AWS account once you've done with your project and you no longer need that account is the responsibility and only can be performed by the root user. Activating IAM access and billing and cost management is another tool that only the root user can perform. So then it can give access to other administrators to view the billing and cost management console, signing up to the AWS US Gov Cloud, registering as a seller on the Reserve Instance Marketplace, and configuring an S3 bucket to enable MFA are just some of the actions that only the root user can perform. IAM password policies. This is another question or topic that you'd like to see tested on the exam. So what are IAM password policies? Very simply, they allow you to define a password complexity rule for the account. And any user accounts, any IAM accounts you create in that AWS account will have to conform to those password complexity rules. So you can do things like, I want 12 characters in the password for your IAM users. You want to use a combination of uppercase, lowercase numbers. You want to set an expiration for that password. Every 60 days, you want your IAM users to change their password to enhance security, and so on and so forth. So remember, IAM password policies is a feature that allows you to define password complexity rules for your AWS account. Let's talk about IAM itself. So with IAM, it allows you to create IAM users and groups. And IAM users basically are, in addition to the root account, you can have IAM users to represent your colleagues in your organization. Now, these IAM users can be member of IAM groups. So Alice, for instance, is a member of the developers group. And you can apply permissions directly to Alice, or you can apply permissions to developers, which means Alice will inherit those permissions as well. In addition to that, you can also create IAM roles. Now, an IAM role is an independent identity that can be assumed by any other entity with the permissions to do so. Okay, so an IAM role grants temporary credentials to grant access to services and resources based on a set of predefined policies. So let me explain what that means. With IAM roles, what it means is that, let's say that you have an application running on this server, and it needs to access some files on this bucket. Now, in order for the application running on the server to connect to the bucket and access the bucket, it needs a set of permissions. You need to allow the application, you need to allow that instance to be able to communicate with S3 and access that particular document or object. So the way how we do it is we assign a role to the bucket. We basically set up a set of permissions, and the permissions are attached to the role. So the permissions say, whoever has this role can access the resources in this bucket. And then we attach the role to the instance in the form of an instance profile. So now we've taken the role, we've added permissions to the role to say that the permissions allow you to access resources in this bucket. And then we attach the role to the actual EC2 instance. Or in other words, the EC2 instance now has the permissions to assume this role. Once that's in place, the application running on the instance can go ahead and access the resource on the S3 bucket. For instance, uploading some log files to an archive bucket as a typical example. So IAM roles allow you to do that. IAM roles allow you to grant resources or permissions to one resource to work with resources of a different service. Now, in addition to that, IAM roles also allow you to do things like, so here's another example, an IAM role allowing, access for a Lambda function to be able to work with objects in an S3 bucket. So the Lambda function requires permission to connect to that bucket and manipulate the objects in that bucket. So it too needs permission, and that can be granted via an IAM role. That's what we call a Lambda execution role. You can also use IAM roles to grant cross-account access. So for instance, Alice over here is currently working in the Richard Rose production account, but maybe she needs access to the dev account. Now, there are two ways of doing that. We could create another IAM user account for Alice in the dev account, but then Alice has to remember two sets of credentials, which is a bit annoying. Instead, what we can do is we can create an IAM role in the dev account. We can give that IAM role the necessary permissions. So for instance, permissions to access the S3 bucket or work with databases, etc. And then we can allow Alice in the production account to assume that role. Okay, so Alice can assume this role that's in the dev account. And by doing so, Alice can now be granted the ability to assume this role. So Alice will need permissions to assume the role. That's all she needs. And then she can go ahead and actually access the resource in the dev account by performing what's known as a role switch operation and performing a cross-account access action. So we have two options. If Alice in the production account needs access to a resource in the dev account, either we create another account, another IAM account for Alice, which is annoying, cumbersome, and Alice has to remember two sets of credentials, or we can create a role, allow Alice to assume the role, and the role has the permissions to access the necessary resource. Alice can then switch roles to the dev account, perform a cross-account action, and then she can access that resource using the credentials of that role. And that's a lot more easier to manage. It also is a lot more secure because these permissions are temporary. They give you temporary access to resources in other accounts in this particular instance, which means they expire after a short duration. And as long as you continue to have permissions to assume the role, you will obviously get your credentials renewed. But the minute that is taken away from you, you cannot access those other accounts. So it adds an additional level of security. It's much more secure than having to remember multiple usernames and passwords, multiple set of access keys. It's also very useful for things like allowing third-party organizations to grant access to resources in your account. It's a far more secure method of doing so. Using IAM roles, you can also do things like on-premises identity federation, which makes it, again, a lot easier for you to manage credentials information and ensure that users in one account can have one single source of truth, that is one set of usernames and password, but be able to access resources in other accounts in other organizations. So the benefits of IAM role is that it offers temporary credentials, and the drawbacks, obviously, of not using IAM role. The drawbacks, obviously, is that you got the issue with long-term credentials, but when you have cross-account, it also creates complexity. But essentially, what you want to take away from this slide is the fact that IAM roles gives you those temporary credentials that allow you to access resources, allow resources to access resources of other services, as in the case of this EC2 instance accessing resources on this S3 bucket. And so that becomes a highly beneficial feature. Let's talk about the identity center. So IAM gives you the ability to create IAM users, IAM roles, IAM groups. And generally, you would use IAM to create IAM roles. to grant temporary credentials for cross-account access or to allow resources of one service access to resources of another service. But if you want to manage your workforce identities across multiple AWS accounts, there's another tool called the Identity Center. So the Identity Center is a service. So let's say we've got multiple AWS accounts. So we've got the production account, we've got test account, we've got a dev account. And the way how this works is you've got a tool called the Identity Center that allows you to create either a locally hosted identity provider. Okay, so the Identity Center itself is an identity provider, or you can integrate it with external identity providers like Active Directory, for example. With the Identity Center, you can create identity groups like developers. So we've got our developers there and our server administrators. So we've got two different groups here. So you've got server administrators and you've got developers. And let's assume that this developer needs access to resources in the dev account. But she may also need access to resources in other accounts. Now, if you're using IAM, you would have to create IAM roles in each of these accounts and allow Alice to be able to assume each of those roles and perform role switch operations individually across them. It's doable. It avoids Alice having to remember 4 or 5 different credentials, but it's still a bit complex. The Identity Center takes away that complexity. It allows you to have a single sign-on capability to multiple AWS accounts in an AWS organization. So for example, here, what we can see is we've got the dev account, the test account, the product account. We can define a set of permissions, which allows us to create some policies. So we define what, the policies are, what you can do in each of those accounts. And then with that, you can define both manage and inline policies. And those policies can have a timeout period. So maybe, 1 hour or 4 hours. And you can set a timeout on those policies. And those policies define exactly what you can do in these other accounts. So then you can attach the policy to a particular account, what is known as a permission set, and a user can be granted access to a specific account. So this user, Alice, can be granted access to the dev account, the test account, and the prod account. So in this scenario, I'm just saying that she's got access to the dev account with a necessary set of permission sets. So what it is that she can do in the dev account. And using that, she's then able to access the portal. And in the portal, she can then connect to the specific account. So in this case, for instance, the dev account to access a specific resource in the dev account. What it also means is that if we give Alice access to the test account and product account, she can just use this one simple portal to access all of the other accounts. She doesn't have to do that complex role switch operation every time, as she would have done just using standard IAM. And I don't need to create IAM roles in each of these accounts, which is adding to the complexity. So the AWS Identity Center is designed for managing your workforce identities and ensuring or granting single sign-on capability across multiple AWS accounts in the AWS organization. It also allows you to have your on-premise users access to your AWS accounts in the organization, as well as use single sign-on services to third-party SaaS providers like Office 365, Salesforce, and other tools and services. So it's seamless access to multiple accounts across the organization, and identity users are assigned with temporary credentials to access those resources. This timeout period will end. You set the duration, whether it's 1 hour, 2 hours, 4 hours, whatever it might be. And then after that, they'll need to re-log in again to the portal. But it means that you've got a better, secure method of managing your resources. Okay, there is actually a lab exercise that you can try out, and I've shared a link over there. All of these slides are available to you at the end of this session, and you can just click on the link to go to that YouTube video that will show you how to set up an identity center service in your own AWS organization. So do give that a try in your own spare time, or if you're working for your organization or your business and you need to set up the identity center, it'll give you some good hands-on experience. Let's talk about Cognito. So we've got IAM. Earlier, we spoke about IAM that allows you to manage identities like IAM users and IAM roles. And to be honest, in this day and age, you're using IAM primarily to manage IAM roles, set up and create IAM roles. If you want to manage workforce identities, remember, you want to use the Identity Center. That's the recommended approach. AWS wants you to use the Identity Center for it. I want you to remember that for the exam. But what about application user access? So when you build this wonderful application and you host it on AWS, what about end user authentication? That's where Cognito comes in. So Cognito allows you to basically create something called a user pool that then allows you to manage your app users, your end customers, the users who are using your application. And they can come in and basically do things like sign into your application or even sign up for your application. And Cognito can manage that entire process for you. You can either have your developers build these functionalities, sign in and sign up capabilities as part of your application, or take that element of it away from them and use Cognito instead, which reduces the burden, but also enhances the way how security is managed in your organization. So the Cognito service basically allows you to use your app to grant them access to a user pool. Once you create the user pool, which is a collection of usernames and all of their details and their passwords and stuff, once they authenticate against the user pool, they get access to a token. That token is then used to grant them access to API gateway, for example, which can then give them access to the backend application that they need access to. And the way how this works then is that you're managing all of the credential part of your application away from the application stack using Cognito. You can also integrate Cognito with third-party identity providers like Facebook, Google, Amazon, etc. Or you can use Cognito's own user pool instead and Cognito's own user pool identity provider. We also have something called identity pools. Now, the way how identity pools work is that they give you the ability to use IAM roles and permissions to grant you access to a whole host of different services on the AWS platform. And so here again, what happens is the application user uses the application to access and authenticate against the user pool. They get a token. That token is then exchanged for AWS credentials. And those credentials are then used to access backend services like Workspaces, DynamoDB, Amazon S3, etc. Okay, so in the previous example where we were using user pools, you'd have to make use of a front-end service like the API gateway to get access to your application. But if you want to give direct access to backend services like S3, DynamoDB, etc., you can use the identity pools service, and you'll be using a combination of the user pool and identity pool services for this particular use case. Okay, so before we go any further, just a quick recap. You've got AWS IAM, which is allowing you to create IAM users, groups, and roles. Today, you really want to use IAM just for managing your IAM roles. You don't really want to be creating IAM users for your workforce. For your workforce, you want to use the Identity Center because the Identity Center gives you single sign-on capability across multiple accounts in the AWS organization. And then finally, you've got Cognito, which is the application layer authentication service to manage authentication for your applications, allowing you to sign up and sign in to your applications. So this could be like a Instagram type application or a Netflix type application, that kind of thing. The next thing that I want you to quickly think about and remember for the exam is there's a service or a tool or a feature of IAM called Credentials Report. So the Credentials Report service gives you a list of all of your IAM users and a breakdown of what they've been doing in your account. So like, when was the last time when were they created, whether they've got a password enabled, when was the last time the password was used? So when did they log into the AWS account? When was the last time they changed their password? So this is really critical information that you can download on a regular basis and just monitor your user base. So for instance, we've got 2 users here, Dorian and John, who have never logged in. Perhaps they don't work for the organization anymore. Maybe we should be just deleting those accounts. So it's a good audit tool for you to use, and that's the Credentials Report. There's another tool called the Access Analyzer. You want to remember this for the exam. The Access Analyzer allows you to monitor external and unused access to an organization. And IAM Access Analyzer will review resources for external access and IAM users and roles for unused access in a specific organization or individual account. Okay, so it allows you to generate some findings of unused access granted to IAM users and roles, and for external access granted to a resource from outside of your zone of trust. Okay, so maybe you've given access to some external third-party accounts. You want to basically see and monitor that as well, and then take necessary actions accordingly. Okay, so these are two audit and monitoring tools: the credentials report and the access analyzer, and they're likely to show up in the exam, so watch out for that one as well. Okay, that brings us to the end of this slide. What we're going to do is take a quick, short 5-minute break, and then we'll come back after 5 minutes. I'll let you grab some tea, coffee, or something, and I'll see you in 5 minutes. If you've got any questions, feel free to post them on the chat as well. Okay, so what we'll do next is we'll get started again. We'll continue from our break. So we're going to move on to Amazon S3 next. Okay. And again, like I said, we're focusing clearly on some core concepts and topics that you need to know in order to prepare for the exam. So I want to make sure that you have all of the resources and that you have a good revision material to refer to as you prepare for the exam. So let's go ahead and get started. Sorry, just give me a quick second. Okay, so there's a quick question that got popped up in the Zoom chat about the fact that, how would you grant access to a user outside of your organization? You would use IAM roles for that. Okay, so if you've got a user in an AWS account that's external to your organization, then you would grant access to that user into your AWS account or accounts using IAM roles. The identity center is used specifically for users within your organization. Okay, so that's something that's really critical. Okay, so let's move on and talk about S3 next. So Amazon S3. So here we are. Okay. Okay, sorry. So let's get started. So basically with Amazon S3, the key things that you have to remember with Amazon S3 is that it is an object storage solution and it allows you to create buckets and objects. It also allows you to replicate objects across buckets. Now, some of the key features of Amazon S3 is that when you create an S3 bucket, the names have to be globally unique. And this is because buckets are accessible on the public internet. Obviously, you can when you first create them, they are private. Okay, you can't just access them, but you can enable them for public access. And for that reason alone, the names associated with your buckets must be unique. So if you try to create a bucket name like marketing or finance, you will find, in fact, you can't get that name. You may need to do finance hyphen my company name or something, which is your company name. They can be 3 to 63 characters in length. They can be a combination of lowercase letters, numbers, dots, and hyphens. They cannot start with an IP address. Okay, so you can't have 192.168.1.7 mybucket.com or something. You can't start with an IP address. And there's a 100 soft limit or a 1,000 hard limit. AWS also allows you to create buckets across regions. So you can create buckets in US East 1 and EU West 2, wherever you might like. But bear in mind that they will never replicate data between buckets across regions. However, you can do that if you wish, but AWS never replicates data to other regions unless you configure it to do so. AWS gives you the ability to store data in your S3 buckets in a manner that increases durability and availability. It gives you 11 nines of durability. Okay, it basically replicates your data across multiple devices, across multiple availability zones in the region in which you've created your bucket, and is therefore able to give you 11 nines of durability. It allows you to fulfill your compliance and data sovereignty requirements because the AWS will never replicate the data from one region to another of its own accord. It is ensuring to you that your data will stay in the region in which you've placed it in. Obviously, you can choose as a customer to copy the data to a different region if you don't have any such compliance restrictions. So Ellie, for instance, our CEO could decide to replicate data from the US East 1 North Virginia region to the EU West 2 London region. Let's talk about objects. So when you create an object, the object can be anything from 0 bytes to 5 terabytes in size. The key of the objects are defined as key values. So key being the name of the object. So in this case, blueberry-muffin.jpg, and the value is the data that is held in binary, which in this case is a nice blueberry muffin. So it's an image. The file structure of an S3 bucket is always flat. Like it's unstructured. Okay, so by default, your normal S3 buckets come with a flat file structure, and all of the data, which are individual objects, are stored in their entirety in your bucket. However, having said that, so you've got these different objects. You've got blueberry muffin recipe. So these are the documents, okay, which are your objects. And they are held as individual objects in their entirety. They've got a lot of metadata around them to describe them, to tell you what size they are, what storage class they're in, and all of that stuff. But it's unstructured data storage. However, you can use what are called prefixes and delimiters to categorize your data. And this gives a visual representation of a folder structure. Okay, so visually this appears as a folder hierarchical structure where you can have things like, your latest and then the document, or your archive and then a previous version of that document, and so on. So prefixes and delimiters are used to basically categorize your data. They can give the appearance of folder and file structure. The other thing to bear in mind is that with the use of such categories, what you can do is you can actually improve the performance of your read and write throughputs on your S3 bucket, because that's done parallelly and it's done based on the number of prefixes you have. So that's an advanced topic, obviously, but essentially prefixes and delimiters, the usage of them can enhance your performance of your S3 bucket as well. We also have versioning, so you can create different versions of a given object and store multiple versions of the object. So that comes handy when, for instance, you're making changes to a particular object and you want to keep the previous versions rather than overwrite them. You need to enable versioning for that in order for that to happen. But bear in mind that enabling versioning is also going to increase your cost. Okay, when you have versioning enabled, just something to be aware of, when you try to delete an object, if you don't specify the version of the object you're deleting, it doesn't delete the object. It just simply adds something called a delete marker on the object. So it essentially hides it from view. You can then basically delete that delete marker to make that object visible again on the front end, if you will. But essentially what versioning does is it allows you to store multiple versions of your particular object. If you do need to delete a specific version, then at the delete operation, you need to specify the version ID that you attempted to delete to permanently purge the object version from the system. Otherwise, by enabling versioning, you actually avoid accidental deletion of your objects or accidental overrides of your object. Okay, let's talk about storage classes. And this is one you're going to be tested out in the exam. In the exam, you're going to get a few questions that will get you to choose which storage class would be the most appropriate for the S3 bucket. So for example, you got your standard storage class, which is the default storage class. This is by far the most expensive storage class, but it's ideal for things like static website hosting because you need constant instant access to the objects like the images or the videos, etc., in that bucket. So if you need single millisecond latency access and you need instant access to it at any time, the standard storage class is the one to go for. You have standard infrequent access storage class. This is for infrequent access of your data, where you need instant access to your data, but you're not going to be frequently accessing your data. And if that's the case, the standard infrequent access storage class is a lot cheaper than the standard storage class. Now, to enforce the fact that you don't misuse this class, there are certain restrictions. So for instance, the object size should be 128 kilobytes in size as a minimum. And if you put anything in this class, it should stay there for a minimum of 30 days. There's also some retrieval costs if you're constantly accessing a particular object, and it really should be sitting in the standard storage class. So then it kind of like defeats the whole purpose of having it in this class. There's a standard one zone IA. Now this is even cheaper. than the standard IA storage class. But the problem with this class is, well, it's not really a problem. The caveat with this class is the data is stored in a single availability zone. Now, AWS will choose a particular availability zone to store the data in. It's not replicated across multiple availability zones. So what it means is that if that availability zone has an outage, you can't access your data until the availability zone comes back online. And in the worst case scenario, you could lose your data as well. Then we have the Glacier storage class. So the Glacier storage class is for infrequent access. It gives you single millisecond latency, and it is designed for archival storage, but the Glacier instant retrieval feature gives you instant access to your data. So it's designed for you to store your data for at least 90 days. Okay, so you're going to rarely access your data. You want to benefit from an archival storage element, but you might need access to it within a 90-day period. And so you can use the Glacier instant retrieval storage class. But it still gives you that single millisecond latency access and is designed to help you reduce your cost overall. We then have the Glacier flexible retrieval storage class. Now, this is designed for instant access, but where you will need to wait for a short period of time before you can actually get your data. So that it needs to be done, it needs to be retrieved from archive first. And again, here you have a 90-day minimum storage requirement in which your objects need to be stored in order to use this class. If you move the object out of the class before the 90-day period end, you're still charged for the full 90-day period. So that's just something to be aware of. There are 3 retrieval options, and depending on which one you choose, the cost changes. So there's the expedited retrieval. If you happen to urgently need access to a subset of your data, then you can get it within 5 minutes. There's a standard retrieval, which means that the retrieval period can take anywhere between 3 to 5 hours. Or if you're retrieving in bulk, massive amounts of data, then you can go with a bulk retrieval. 5 to 12 hours would be the maximum duration you would have to wait before you can get access to your data. But obviously, it's cheaper than all of the other storage classes, and it's designed for really archival storage. We also have Deep Archive, which is the ultimate archive storage, cold storage, if you will. And that's designed for infrequent access, where you're happy to wait for at least 12 hours, and for bulk retrieval, even up to 48 hours before you actually get access to your data. There is a 180-day minimum storage requirement, so the data must stay in that class for 180 days as a minimum. You are charged for 180 days of storage. But it's the cheapest class on the system, on the platform. Then we have intelligent tiering. Now, intelligent tiering is interesting. Intelligent tiering is designed for data where the access pattern is unknown. So you don't know whether your colleagues are going to be accessing the data next week or maybe after 3 months. And then if they access it next week, suddenly they'll need access to it again after another couple of days. So that access pattern is really unknown. So objects placed into the intelligent storage class, intelligent tiering storage class, is monitored, and using machine learning, AWS will decide and manage your objects across 2 sets of classes. Okay, one is the frequent access class and one is the infrequent access class. There's even an archive instant access class as well. So essentially what this means is that we have a frequent access tier of the intelligent storage class where data is stored for frequently accessed data. If you don't access that data for 30 days, it is shifted into an infrequent class. So it drops down the price, so it's cheaper. If you try to access it in that 30-day period, it gets shifted back into the frequent class. So the object actually moves between the classes. If you don't access it for 90 days, it gets moved into the archive instant access tier. And obviously then it becomes even more cheaper. If you enable archive classes, so this is an additional feature, this is an optional feature. If you enable archive access, then basically after the 90-day period, it is moved into the Glacier archive class. And then if you don't access it for 180 days in total, then it's moved into deep archive access. So AWS will shift the object between the classes based on your access patterns, based on how you're accessing the data. So the idea is that if you enable the archive feature as well, and you haven't accessed an object for 180 days, it actually gets moved into the deep archive access, and it stays there, costing you far less than it would sitting in a frequently accessed class. Okay, and that's an optional feature, but you can enable that as well. So the cost is based on the storage fee per gigabit per month for the data stored, the amount of transfer out, the request fee per 1,000 requests. AWS Intelligent Tiering will monitor your usage pattern, and so there's a monitor and automation fee per object, but there are no retrieval costs. There is a newer class, well, I say new, but it's been there for a little while now, called the S3 Express One Zone Storage class. Now, I've been talking to you about the fact that the storage on S3 is flat file unstructured. This one is different. This is a directory bucket. This allows you to actually store your data in a hierarchical directory structure. It's a single availability zone storage class. It's designed to give you frequent access with single-digit millisecond latency access. So those applications that require single-digit millisecond latency access will benefit from the data that's held in the Express One Zone storage class. So it's 10 times faster than standard storage class and 50 times cheaper than the standard storage class. So it's 10 times faster than the standard storage class. And the directory buckets are organized, and directory buckets organize data into directories. There's no prefix limits or horizontal scale. It's horizontally scalable. There's no prefix limits to it, so you don't have to worry about those prefix limits. And it can support hundreds of thousands of transactions per second. So that's another really cool feature for this particular storage class. It also allows you to ensure that you can co-locate the bucket in the same availability zone as where you're hosting your compute EC2 instances. So it gives you that ability to decide which availability zone it should be in so that your instances can get that single millisecond latency access to that bucket. So use cases are things like generative AI, ML training, transaction tables, data lakes, video content creation, financial model simulations, genomics processing, image rendering, and so on. The cost for this is based on the gigabit per month of storage used per hour. It's charged based on the request type, so the number of puts and gets. There's an additional gigabit fee for a portion of request side exceeding 512 kilobytes. But what I want you to remember is that the Express One Zone storage class is a directory bucket. Okay, it allows you to host directory buckets. It allows you to store the buckets in the same availability zone as your EC2 instances, and it gives you that single-digit millisecond latency access. Lifecycle management is another key topic that I want you to remember for the exam. This allows you to set up rules to transition objects from one storage class to another based on time duration. So maybe after 30 days, you want to shift version 2, the latest version of the object, to standard IA, and then after 90 days, you want to shift it into Glacier. Whereas version 1, an older version of your object, well, you're probably never going to access it. So maybe after 90 days, we should just shift it into deep archive. So you can build these individual rules, these transitioning rules in your lifecycle management. And ultimately, you can even create a rule to expire the object, to purge the object from the platform altogether. This allows you to manage your costs more effectively rather than have very old stale data sitting in S3 incurring unnecessary charges. So those are the expiration rules. So next, very quickly, with S3, you can create bucket policies. So with IAM, you create IAM policies, which are attached to IAM users and roles. But with S3, you can also create bucket policies, which are called resource-based policies. These are attached to the actual S3 bucket or the resource and enables you to grant permissions externally to external resources. If you need to grant anonymous access to your bucket, you can only do that using bucket policies. IAM policies cannot be used to grant anonymous access because IAM policies, by definition, need to be attached to an IAM user or an IAM role. And you can obviously have conditional statements that say, under what conditions you're going to grant access to this bucket. This also is a very critical feature because with the anonymous access element, that's where the static website service that you can set up on your S3 bucket actually comes into play. Because with static website hosting, it's based on the idea that your bucket and the contents of that bucket, rather, are available for the public domain. There's another key feature of the S3 service that I want you to remember for the exam, and that's the S3 transfer acceleration service. So normally when you're uploading and downloading objects to your S3 bucket, like if you need to upload some videos or whatever, you're going to be using the standard internet to basically connect to your bucket and upload your objects to your bucket. And that means you go via the public internet routes through the various hops, through the various routers across the internet to get to your bucket. And obviously the public internet gives you a certain amount of speed and connectivity. With transfer acceleration, what happens is when you upload your objects, you upload them via a transfer acceleration endpoint. That transfer acceleration endpoint is sitting closest to you at the closest edge location to your location. So when you perform an upload using transfer acceleration, it connects to a closest edge location and it uploads it via that edge location, which ultimately goes over the AWS backbone net, which is a lot faster, a lot more throughput, a higher bandwidth offering. And so in this screenshot over here, you can see that with transfer acceleration, upload completes, giving you 434 times faster than standard internet upload to North Virginia, for instance. And likewise, using transfer acceleration, your speeds will be much, much better. So just remember S3 transfer acceleration for the exam. Storage gateway. Storage gateway allows you to build hybrid cloud connectivity or hybrid storage connectivity between your on-premise locations and the cloud. We've got three different types of storage gateways. You've got the file gateway that allows you to access data held in S3 using standard file protocols. Okay, so standard file protocols like NFS or SMB. You have the volume gateway, which offers two different options, the stored volume and the cached volume. So volume gateway allows you to connect your applications to cloud storage over that gateway service. And you can either use the cached volume, which basically means that you are hosting frequently accessed data locally in cache. So you need a few storage devices. Or if you have the stored volume, you would have all your data on premise and then perform multiple backups to or snapshots to the AWS S3 platform. This uses things like standard iSCSI protocols, for instance, to help you connect and build that hybrid connectivity. And then finally, you have tape gateways. So quite a number of organizations still use tape devices to manage their backup strategies and their backup processes. Instead of using physical tapes, you can use a virtual tape system where the data is then stored in Amazon S3. And you can use a tape gateway solution, S3 tape gateway solution, to have your backup application perform backups directly into S3 onto what are called virtual tape devices. Okay, so storage gateway allows you to build hybrid storage connectivity between your on-premise location and the cloud. You've got file gateway, volume gateway, and tape gateway services available to you. Okay, we'll come back to Snowball in another slide. Let's move on to the next topic. Okay, we're going to move on to networking next. Okay, so networking is our next topic for the day. And we're going to talk about networking services on AWS. Now, when it comes to the exam, you're going to, again, get quite a few questions on the networking side of things as well, from a high-level perspective, looking at networking services available on AWS. So let's take a look at that next. So VPCs first. VPCs basically allow you to build virtual private clouds or virtual networks in the cloud. They span the entire region. Okay, they don't span across regions. This is something you must remember for the exam. So VPC spans the entire region, and that means it spans across all of the availability zones in a region. So in the UK, we have the London region, which has got 3 availability zones. It will span across all 3 availability zones. In North Virginia, which comes with 6 availability zones, your VPC will span all 6 availability zones. Within those availability zones, though, you will create your subnets. So you got public subnets and private subnets. Public subnets is basically a subnet that is connected to a route table that gives you direct access to the internet gateway. Private subnets are those that do not give you access directly to the internet gateway. And so the idea is you host private resources there that do not need to be accessible directly from the internet. Like a front-end web server does not needs to be accessible from the internet, maybe, and even that's debatable. But most of your resources are going to sit in the private subnet. The resources you put in the public subnet are only ones that you want to expose out onto the internet, that you want users on the internet to be able to connect to. Okay, so your VPC comes with an inbuilt router, as well as the ability to create an internet gateway, which grants it internet access. And within that, you can also, as I mentioned, have route tables. So your route tables basically allow you to define how resources in the subnets route traffic. So if you've got a route table, any instances that you deploy in the public subnet can route traffic to the internet via the internet gateway directly. Those resources would also need to have public IP address, however. Resources in the private subnet and things like EC2 instances running app servers or databases, they do not have direct access to the internet. But using the private route table, they can access the internet via something called a NAT gateway. So NAT gateway stands for Network Address Translation. It is there you can create and deploy a NAT gateway so that resources in the private subnet can also access the internet, but indirectly via the NAT gateway. Okay, so they don't connect to the internet gateway directly. You can think of this as similar to your home router. Okay, so you have a home router or a home modem. Your laptop at home has only a private IP address, does not need to have a public IP address, but it can still access the internet via that router. And that's something similar to what this is. So this is a NAT gateway. Your home router is also offering you NAT services. In addition to that, when it comes to security, you've got 2 sets of firewalls you can deploy in your actual VPC. You've got network access control list, which protects the subnet, and you can define what traffic allowed to go into and out of the subnet. And then you've also got the ability to create security groups. These are firewalls that are associated with specific resources, the actual instances. So you've got the network access control list that allow you to define what traffic can enter the subnet. And then within the subnet, you've got security groups that further define what traffic you can allow to actually access the instance or the resource. Okay, so you've got security groups and network access control lists. And here, what I'm trying to demonstrate is that you can use your security group to really define exactly how traffic is allowed to come to resources within the VPC. So we've got these databases. These databases have a security group called the VS Data SG. That's just a name. But we are saying that it allows MySQL traffic, and the source of that traffic is VS App SG, which is this security group. So the VS App SG is associated with these instances, the app server instances. Okay. In other words, the only resources that can talk to these databases are these instances. In addition to that, we're saying that the VS App SG can allow inbound traffic on HTTP, so that's normal port 80 traffic, and the source of that traffic is VS ALB SG, which is this one over here. So this is a load balancer SG, and this is defined to allow load balancers to be deployed in your VPC so that they can connect to your EC2 instance. You can also create endpoints. So all of these services are built and deployed in a VPC, your instances, your RDS, databases, etc., your NAT gateways. But a lot of other services on AWS are not deployable within a VPC. They are what are called public services, AWS public services, like Amazon S3. Now, if you need to access Amazon S3, if this particular server sitting in a private subnet needs to access S3, if you did not use an endpoint, it would need to send traffic via the internet gateway. So it will send traffic via the NAT gateway, via the internet gateway, and then back to S3. Or if you want private connectivity to S3, you can create an endpoint for your VPC that gives it access to the S3 service. And that traffic will be private in AWS's private backbone network. Some key important points of your VPC is that the maximum VPC CIDR range is a /16, the minimum /28. VPC spans the entire region. I want you to remember that for the exam. Subnets span entire availability zones, okay? Or subnets span the availability zone only. So just be aware of that. Security groups are stateful, which means once you create them, you define inbound rules, the corresponding response to the inbound request will be automatically replied to. They're firewalls for the instance level, so they attach, or rather the instances are attached to those security groups. They're only allow rules, so they define only allow rules. You cannot create any deny rules. Everything is denied by default, and then it's just which rules you're going to allow. You're going to allow inbound port 80, inbound port 443, that kind of thing. Network access control lists are stateless, which means you've got to create the inbound rule and its necessary corresponding outbound rule as well. Okay, so if you're allowing inbound port 80 from the internet, you need to ensure that the outbound port 80 to the internet is also permitted. In fact, you need to ensure that the outbound port ephemeral ports, the higher level ports, are permitted out to the internet. They're firewalls at the subnet level, so they protect the entire subnet. And with NACLs, you can actually create both allow and deny rules. So let's say we are allowing inbound port 80 for HTTP traffic from the entire planet, but there's a small corner of the globe with a specific IP range that we want to block. We can block that particular access from that specific region. Okay, so it allows you to create deny rules as well. Right, another key topic that you might see in the exam: how can you monitor your IP packets that are coming into and out of your VPC to see what traffic is allowed in, what traffic is being rejected, what traffic is being accepted? VPC flow logs is the answer. So VPC flow logs allow you to monitor IP traffic for your VPCs, for your subnets, and individual network interfaces. So watch out for that one in the exam. Another key topic that you might see in the exam is that can we connect two VPCs together and so the traffic from one VPC can go to the other VPC? And the answer is yes. We use something called peering. VPC peering connections allow us to ensure that resources in one VPC can talk to resources in another VPC. However, with VPC peering, you've got to understand that this is an explicit one-to-one connection. Okay, so if you have thousands of VPCs and they all need to connect to each other, you have to explicitly create a peering connection between every VPC pair. That might be a bit of a problem, certainly from a management overhead. And so you can do instead what's known as, as a transit gateway. So a transit gateway allows you to connect multiple VPCs to each other using what's known as a hub and spoke model. So the transit gateway is the hub and the VPCs are the spokes. And if VPC A is connected to the transit gateway, then by definition, it can talk to resources in B, C, and D as well. If you're using just peering, each VPC pair has to have its own explicit peering connection, which is very difficult to manage. Okay, so if in the exam you're seeing a question that talks about, having multiple VPCs connect to each other, so that they can all talk to each other or something along those lines, transit gateway. If you've just got two VPCs that need to share some traffic, VPC peering is enough for that. Direct Connect is another service that's offered to you. So this is where we are connecting from our on-premise location to the cloud. Now you can use standard internet and VPN, so we'll talk about VPNs in a second, or you can use Direct Connect. Direct Connect is physical cabling that is laid down and allowing you to connect privately to the AWS platform. So you do not traverse the internet in this case. So we've got our customer network. You have a customer router that is used to connect over private cabling to a Direct Connect location, usually a Direct Connect partner, an AWS partner, like a telecommunications company. And then the customer will connect to their partner or their customer router in the Direct Connect location, which is then crossover to the AWS Direct Connect endpoint that gives it access to the region in which it is in, to the AWS environment of that region. Okay, so Direct Connect gives you direct connection using private cabling, does not go over the internet. It's more expensive, obviously, than standard VPN connectivity, but it gives you higher bandwidth, higher throughput capabilities. And it's a private connection rather than one that traverses over the internet. Let's talk about CloudFront. So CloudFront is a service that helps you build content delivery services for your organization, for your application. So let's say, for instance, we've got all of these users that need to access the S3 bucket. Now, with CloudFront, what happens is users will access the edge location, okay? And from the edge location, they will be accessing the contents that are available in that bucket. And what CloudFront does then is it caches content that's been accessed at the local edge location services. So any content in this bucket will get cached at the edge location if a user attempts to connect to it via the CloudFront distribution endpoints. This means that the next user that tries to access the same content will just retrieve it from the edge location. So this reduces lag and latency substantially, okay? And it also obviously eases the burden on the end origin resource. So this allows you to distribute your content more effectively across the globe. Okay, CloudFront distribution is often used by a lot of organizations that are distributing content like videos, images, documents, and even standard sort of session connectivity, but it gives you faster throughput, low latency connectivity to data. Okay, so very quickly, I also want to cover Route 53. You're likely to see Route 53 come up in the exam. Now, Route 53 is AWS's DNS service offering. So in this example here, what we're saying is that users need to connect to richerroast.io. That URL is defined in a hosted zone configured in Route 53, which apparently points to an application load balancer that then gives them access to the app service that is hosting that application. So Route 53 allows you to use DNS, allows you to configure your own domain names for your customer vanity domain names, so whatever your customer domain names are, and configure aliases for those domain names to various resources in the AWS platform. So Amazon S3 website hosting, application load balancers, Elastic Beanstalk environments, and so on. So with Route 53, you can also register new domain names. So if you want to buy a domain name, you can do that on Route 53 itself. You create hosted zones to connect to services within AWS and even externally. Route 53 can perform health checks and monitoring against your resources to see if your load balancer and the resources behind it are functioning before it sends traffic to it. It can route traffic globally and help you achieve high availability. So for instance, you can have resources in multiple regions, and you can distribute traffic between those regions using Route 53, using various routing policies. So for instance, you've got a simple routing policy, which is simple, okay? It basically gives you access or allows you to configure an endpoint for a particular domain name. We've got failover routing policy. This is where you want to create an active passive setup. So let's say you have your main website hosted in the UK, in London. And if there is a huge disaster and the entire region goes down, you want customers to be redirected to a different region hosting a secondary copy of your website. So maybe Sydney, Australia. Okay, so you can configure failover routing policy to allow you to achieve that. With failover routing policy, your primary site is the UK, for instance, is the London region, and your secondary site is sitting in Sydney, Australia. If there's a huge outage, customers are directed to the Sydney, Australia version of your website, and they can continue accessing your web application. That's known as failover routing policy. Geolocation routing policy looks at the location of the end user. So if the user is located in, say, Paris or somewhere in France, they're redirected to the Paris region, for instance, if that's where you're hosting your resource. So geolocation looks at the user's location. Latency routing policy looks at which resource in which region gives you the best or lowest latency and accordingly connects you to that resource. And then weighted routing policy allows you to have multiple regions, multiple resources that you can shift different percentages or different weights of your traffic to. So for instance, you can have 60% of your users directed to the London region and 40% to the Dublin region, to the Irish region. Or you can use it for things like A/B testing. Let's say, for instance, you've got a standard version of your website and now you've come out with a new version of the website. You could use weighted routing policy to send a small percentage of your traffic to the new version with a lower weight, so that you can see how the users are now finding the new version of the website, if it's working, if there are any teething issues to address, etc. And then if that's going really well, you can start changing the weights, reducing the weights on the original site, increasing the weights on the new site, so that you slowly transition all of your users to the new site. So that's known as weighted routing policy. So for the exam, for the Cloud Practitioner exam, you basically need to know that Route 53 is a DNS service, allows you to create domain names, you can perform health checks and monitoring, and a quick high-level overview of some of those routing policies, probably. Let's talk about elastic load balancers. So with Route 53, we're distributing or we're routing traffic across globe, across multiple regions. Within a given region, you can use load balancers to distribute your traffic across multiple resources. So let's say you have multiple EC2 instances. With load balancers, you can actually choose to distribute your traffic across multiple instances through that load balancer. So top of the list is application load balancer, which allows you to distribute layer 7 of the OSI model type traffic. So that's HTTP and HTTPS traffic. The targets can be EC2 instances, IP addresses, Lambda functions, etc. You have network load balancer, which provides support for TCP, UDP, and TLS protocols. It's a layer 7 type traffic. It's capable of handling millions of requests per second. The targets can be instances, IP addresses, and application load balancers. And then you have the gateway load balancer, which is designed for deploying and scaling and managing virtual appliances like firewalls, intrusion detection and prevention systems, and deep packet inspection systems. It uses the Geneve protocol on port 6081, and it operates at layer 3 of the OSI model. So the gateway load balancer is designed to help you distribute traffic across third-party AWS marketplace provisioned gateway services or gateway virtual appliances like firewalls and IPS and IDS systems. The network load balancer is where you need to handle millions of requests per second, operating at TCP and UDP protocols. And the application load balancer is where you're distributing traffic at the application layer. So when you're hosting your e-commerce web application, for instance, and that's running on some servers and you need to send traffic to it. Okay, so those are the 3 different load balancers you need to be aware of. There is a classic load balancer, but you shouldn't really be using that anymore. So the key difference between the ALB is that it operates at layer 7 and supports advanced routing based on things like HTTP and HTTPS requests, while the NLB, network load balancer, operates at the transport layer and handles high-performance routing for TCP and UDP traffic with ultra-low latency. Watch out for the terminology and the wordings in the exam question. You'll be able to select between the application load balancer and the network load balancer. For the gateway load balancer, watch out for things like, virtual appliances, Geneve protocol, that kind of thing. And then you'll be able to select the gateway load balancer for that particular use case. let's talk about VPNs. So you got AWS client VPNs, which allows you to fully manage VPN solutions that can be accessed from anywhere with an internet connection using an open VPN compatible client. It will connect to both AWS and on-premise networks, and the client will be used to authenticate using either Active Directory or certificates. So this is where you have, for instance, your laptop, okay, and you want to set up a VPN connection into your VPC to access some resources in there. You also have site-to-site VPNs. This is where you have a more permanent VPN connection between your on-premise location and your VPC. So this is secure connection between your data center or branch office and your AWS cloud resources. It uses IP security or IPsec tunnels. And you can also have the global accelerator to intelligently route traffic to the nearest AWS endpoint with best performance. So you create a customer gateway. So you need to deploy a physical VPN device on the customer end. So this could be like a Cisco VPN device. And then on the client side, you configure a VPN gateway. And then basically, once you've done that, you'll establish a VPN connection between them. Okay. So watch out in the exam for the phrasing of the question. If it's like, you want to connect a data center to the cloud, what sort of VPN to use? That's a site-to-site VPN. And that's where you would need to configure a customer gateway or a VPN gateway and a VPN gateway. So the global accelerator provides static anycast IP address that's globally distributed to allow traffic to be routed to the nearest healthy endpoint within the AWS region for high availability and performance. And it basically works like a traffic director. It gives an application two fixed IP addresses and uses the fastest and most reliable route in the global network to send users requests to the nearest and healthiest server, making the app faster and more reliable no matter where the users are. Okay, so that pretty much covers the overview of networking and VPN services on the AWS platform. The key takeaway that I want you to do is remember VPNs span entire regions. Subnets span individual availability zones in a region. What is a NAT gateway? You need to know that. What is the internet gateway? You need to know about the fact that there are route tables that allow you to define how traffic flows within subnets and across subnets. You must understand the key differences between a network access control list, which protects the subnet, versus security group, which protects the individual instance. You must also know about Route 53, the different routing policies, what it does, what's Route 53 main use case. You must know about elastic load balancers. You've got the application load balancer, the network load balancer, and the gateway load balancer and their use cases. And then obviously you've got VPNs as well. So we took a look at site-to-site VPN and client VPN. And don't forget about direct connect. Okay, for the exam, you're likely to see at least one question where the answer is going to be direct connect. And that's where you want a private dedicated connection between your on-premise location and the AWS cloud, but you want really high bandwidth, like 1,000 gigabits per second or something along those lines. Okay, so that covers the VPN and the networking section of this revision course. Let's take another quick 5-minute break, and then we'll continue where we left off. Okay, hi, welcome back. So we'll continue from where we left off, and we're going to move on to compute services next and provide you some core concepts that you want to study and remember for the exam. Okay, so let's talk about compute services next. So when you're deploying your resources on AWS, remember, as I said earlier, you're going to be deploying EC2 instances inside of a VPC. RDS databases inside of a VPC. You put in some Lambda functions as well. You choose to place them within a VPC, for example. Now, when it comes to containers as well, they also can stay in a VPC. You've got obviously different types of containers. You've got EC2 instance and Fargate, but ultimately Fargate will inject ENI interfaces into your VPC. So there are certain services or resources, I should say, that get deployed in your VPC. Others are sitting outside of the VPC in AWS's public space, like your S3 buckets and your DynamoDB tables. With EC2 instances, what I want you to remember for the exam is that these are virtual machines in the cloud. They can run Linux or Windows operating systems, and you've also got the ability to run Mac OS as well. They can be deployed in public subnets and can act as bastion hosts or management servers. Bastion hosts are basically hardened servers that are placed in the public subnet to allow you to remotely access them, from which you can then access resources in the backend in the private subnets. Now, you don't need to use this methodology. There's also something called AWS Session Manager that allows you to remotely connect to resources in the backend services in the private subnets without having to use a bastion host. But bastion hosts are used as well. You have web and application service that can be deployed in private subnets. And you may think, why are you deploying web services in a private subnet? Should it not be in a public subnet? And the answer is no, it doesn't need to be in a public subnet, because in a public subnet, you can place things like application load balancers to then connect you to resources in the backend, and the backend or the private subnets can host web servers as well, front-facing web servers as well. And this enhances your security further. Databases also should be placed in the private subnet. You shouldn't really be placing databases in the public subnet unless there's a really specific use case, which should be really rare. But by and large, you should be storing your or hosting your databases in a private subnet. Now, when you create an EC2 instance, or when you deploy an EC2 instance, you define what is known as an EC2 instance type. So you select an EC2 instance type, and that basically defines the amount of compute capability it has in terms of CPU, the amount of memory it has, the network capacity that it's capable of, and the kind of storage that you can attach to it. So that defines the EC2 instance type. I've got a link over here that you should really visit, which gives you a breakdown of the different instance type and families that are available on AWS. In fact, let's quickly do that. So this is the list of different EC2 instance types. And you want to remember the families of the instance type. So you've got general purpose, compute optimized, memory, accelerated, storage optimized, etc. Now, you're not going to be tested individually on, what is an M71? That's not what you're going to be tested on. What you will be tested on in the exam is more about the instance type definition, like what is an instance type? So basically, it's a collection of its compute, memory, and network capability. You may possibly get a question on whether you should go with an accelerated computing, which is designed for things like hardware accelerators and core processors, perform functions, floating point, etc. You may get a question there, although I doubt it personally. Or for instance, would you select a memory optimized with what scenario? Well, where you need to deliver fast performance and workloads that require or process large data sets in memory. Okay, so that might be a use case for using memory optimized. Regardless, you're not going to get too many complicated questions around this area, but it's just a good point to remember for your real world use cases that there are these different families. Within the families, we have our different types, and these individual ones are what are called sizes. So if we go down to general purpose, the T2 is the actual type, And within there, we've got the individual sizes. So the T2 Micro comes with 1 CPU, 6 CPU credits, 1 gig of memory. It's EBS only. It's low to moderate performance level, that kind of thing. So you've got family. Then within the family, you've got type. Then within the type, you have the sizes. Okay. So EC2 instances are deployed in a subnet. And so they're also known as zonal services rather than regional services. So you need to select the subnet you want to deploy it in. EC2 are AZ specific, but as I said a moment ago, they're zonal specific. So they're availability zone specific, and you select the specific subnet you want to place them in. EC2 instances, the way how they work is basically they give you access to network capability and access to storage capability. So for instance, we've got network on the underlying host machine that then is attached as a virtual network interface or elastic network interface to the actual server that gives it networking capability. And you can actually have a server have a multi-home network. So you can actually attach multiple ENIs, multiple network interfaces to your instances across multiple subnets, creating a multi-home environment, a multi-home network. So one subnet could be used for public access, another one could be used for management access, for example. You also have storage networks and storage capabilities. So you can attach EBS volumes to your EC2 instances. Okay, and this is over a storage network. And this means that your volumes, your EBS volumes, are decoupled from your actual instance, which is a really good thing because it also means that, if one instance fails, you can move the EBS volume from that instance to another instance and continue to access the data held on that volume. What you cannot do is have a volume in one availability zone accessed by an instance in another availability zone. Okay, that isn't possible. So that's something to remember as well. Although that's more of an advanced topic for the cloud practitioner. The cloud practitioner doesn't expect you to know this level of depth of technical information, but I just wanted to share this with you so that you're aware about how it all works. So when it comes to choosing an EC2 instance, you need to make a choice on the OS, whether you're going to go with Windows or Linux or even Mac. You've got a range of instance specifications, combination of hardware and software variations to define your instance family, size, and type and size. You can choose to deploy your EC2 instances to host applications, web, and even database servers, although you should probably consider managed database service offerings like RDS and DynamoDB. You can migrate your on-premise service to AWS. And those are the key variations and differences in your EC2 instances. Let's talk about scaling. So when it comes to obviously your EC2 instances, you can start off with the T2 Micro, for instance, and then upgrade that or change that instance type to an M5 Large, right? So you can make those changes. That's known as vertical scaling. But you can also scale horizontally, which basically means that you can add more instances to your fleet to support your application load. So in this example here, when we are deploying an EC2 instance, you can actually scale out as well as scale up. Also, when it comes to deploying your EC2 instances, you can use auto scaling to provision your instances for you. And then you can have the ability to scale between, say, 2 instances to start off with, but then maybe up to a maximum of 12 to cope with extended demand. Now, when you're creating an auto scaling service, you create something called a launch template. In that launch template, you can basically define what AMI to use. So what is an AMI? AMI stands for Amazon Machine Image. It is the image of that instance of that server that contains the operating system, any utilities, any applications that come with it. So the AMI is what you choose. So if you're deploying a Linux 2023, Amazon Linux 2023 AMI, that contains the Amazon Linux operating system and maybe various utilities and services and tools, etc. If you're deploying a Windows 2019 with SQL Server, whatever it is, well, that image comes with the Windows operating system 2019 plus the SQL Server installed on it, pre-installed on it. So you create a launch template. That launch template is then used to deploy or configure your auto-scaling service, and the auto-scaling service can then be configured with a scaling policy to deploy one or more EC2 instances. So these instances will be deployed with that AMI and any other parameters that have been defined in the launch template, things like IAM roles, things like any user data scripts, etc. Now, when it comes to auto-scaling, you can scale manually. You can scale using step scaling. Step scaling is basically where you change the number of EC2 instances you're deploying based on a predefined parameter. So say, for instance, if CPU utilization hits 60%, I'm going to deploy 2 servers. If it hits 80%, I want to deploy 6 servers, and so on. So it's a step-based approach. You also got something called target tracking, where the number of instances deployed is based on a particular target value that you want to always ensure you're achieving. So you're happy achieving a CPU utilization on average in your fleet of 40%. What that means is that AWS will provision only the necessary instances to achieve that target level. So if demand suddenly goes up, if there's a lot of traffic coming in to your application, and CPU utilization on average across the fleet is now 60%, then AWS will deploy an additional EC2 instance so that it can bring it down to 40%. Likewise, if demand has dropped and there are 6 instances, bring it back up to 40%, AWS will terminate some EC2 instances. And then you got schedule scaling for things like specific events or festivals or specific requirements at certain months or weeks in the year where you need additional capacity. You can schedule that scaling policy for that. Also, when it comes to EBS volumes, you must remember this for the exam, that there are 2 types of EBS volumes. You've got general purpose SSD and you've got provision IOPS SSD. Here's a table that I want you to actually learn and go through, specifically focusing on the use cases. So if you require single millisecond latency, then you really want to go with provision IOPS. If you require IO intensive database workloads in your exam question, what type of EBS volume do you need? You need a provision IOPS. If you are just basically using medium-sized single instance databases, general purpose will suffice, and so on. So just read up the use cases and understand the different use cases in order to choose the right answer in the exam. There's a difference between EBS backed volumes and instance store volumes. Again, this is more of an advanced topic, but essentially what this is you can choose to have instance store backed volumes, which are volumes that are attached to the physical host machine of the server on which your instance is running. Okay. The one thing to bear in mind about instance store backed volumes is that if you run a server or an EC2 instance with an instance store backed volume, you can't stop the server. If you do, it will basically terminate or delete the instance volume. So that's something to be aware of. It's ideally used in those cases where you want to use it as a scratch disk, for temporary storage, for buffering, that kind of thing. That's where you would use instance store backed volumes. Otherwise, if you need persistent data, you want to use EBS backed volumes. Let's talk about the EC2 pricing options. Now, you're likely to see at least 2 or 3 questions just on this alone. So this is an important topic. So by default, when you provision an EC2 instance, you're provisioning an on-demand instance, an instance where you're paying by the second, a minimum of 60 seconds, on an hourly rate with no long-term commitments. It's ideal for short-term unpredictable workloads, things like dev work or testing, QA testing, that kind of thing, where the application that you're running on that instance cannot be interrupted. So you don't want AWS interrupting your usage of that service, of that server. But it's not ideal for long-running workloads, for workloads that you're running across multiple years, for instance. For that one, you really want reserve instances. Okay, that's where you commit to a minimum of 1 or 3 year duration. The benefit of doing so is that you actually get a discount of up to 75% when compared to the on-demand hourly pricing. You got 2 different options when it comes to reserve instances. You got standard, which gives you the highest discount, but it's the least flexible. You got convertible, which gives you a slightly lower discount, but you can change the family of the instance. You can change the platform that it's running. You can move it from, one availability zone to another very easily. So it's a lot more flexible when it comes to making changes. And you might want to choose the convertible reserve instance because you may not have, the foresight about how you might use this particular instance in the future. So you want some flexibility. Spot instances are basically where AWS has a lot of reserve capacity that they obviously want their customers to consume so that they can profit from it. And basically it gives customers the opportunity to bid for compute capacity with discounts of up to 90%. At any given point in time, in a given region, in a given availability zone, there'll be spare capacity which will be sold as spot instances. And if you go into the AWS Management Console, you can check the pricing for those spot instances. As long as you commit to paying that spot price or slightly higher, you will be able to provision the spot instance. Now, spot instances may be interrupted. So they're not designed for applications that are going to be affected by such interruptions. They're designed for stateless applications. And they may be interrupted because there's a change in demand and supply, and therefore the spot price has gone well above your offer price, okay? Or simply because they just need the extra capacity because they're running out of capacity. So you may get interrupted. So just be aware of that. Spot instances, if you want to use them and benefit from the 90% discount, you can do, but you need to be aware that you're running applications on them that could get interrupted. So if you're running stateless applications that are not affected by interruptions, fantastic. There's some additional cost-saving strategies when it comes to EC2. So, there's obviously the reserve instances where you need to make a choice between standard or convertible reserve, but there's also things like savings plans. This is where you commit to a consistent amount of usage measured as dollars per hour over a 1 or 3 year term. It offers significant discount when compared to on-demand, but it's flexible across the instance family sizes and regions. So you're not bound to one specific instance type or family as you would with reserve instances. Instead, what you do is you just say, right, I'm willing to commit to, I don't know, $5 an hour for the next 1 year or something like that. And then you use that discounted rate, you get a discount on your on-demand pricing to consume that commitment. Now, there are 3 different types of savings plans. There's this EC2 savings plans. This will give you the largest amount of discount. This will give you up to 72% off the on-demand price, but it's only applicable for EC2 instances. So your money that you've committed is only going to be applicable to EC2 instances. There's a compute savings plans. This is where the amount that you've committed can be spread across other compute services as well. So not just EC2 instances. You can use it against your Lambda functions, against your Elastic containers, your Fargate containers as well. And then there's a SageMaker savings plans, which obviously is for machine learning purposes and all of your machine learning consumption as well. Okay, let's talk about Elastic File System. So we spoke about EBS earlier. We said the fact that EBS is, direct attached storage that you attach to your EC2 instances. They're persistent storage. You can move one EBS volume from one server to another if you need to. But what about file storage solutions? So we've got EFS. EFS is a file storage solution that allows you to basically access a file storage system across multiple servers spread across multiple availability zones in your region. So in this example, we've got EC2 instances across 2 subnets, across 2 availability zones. You can have mount targets configured to connect to a particular EFS file system that you have configured. So the good thing about this is that this is ideal for sharing files between your Linux-based instances. So EFX is ideal for Linux-based instances only, or rather, I should say AWS supports Linux-based instances for the EFS usage. And so that's something to be aware of as well. We've got FSX as well, FSX for Windows file servers. So if you need a file sharing solution, like EFS is for Linux, FSX for Windows File Server is for Windows, and it integrates well with things like Active Directory, giving you all of the core features of Active Directory services associated with the file storage solution. So things like DFS, okay, distributed file system, is another feature of Windows file sharing solution. You can connect over standard SMB protocols and share all of your data across multiple servers using the FSx for Windows file server. You also have FSx for Lustre, which is a high-performance storage that gives you on-demand, short-term, compute-intensive processing of your data sets, and it integrates with S3, where all of your long-term data sets can reside. So the idea is that your long-term data sits in S3. You can pull it into FSx for Lustre to all of your compute-intensive processing against that data, and then all of the results can be shipped back and stored for long-term on S3. AWS Batch is another service, another compute service that is fully managed that helps you run large-scale batch processing workloads by dynamically provisioning the optimal compute resources required, such as EC2 instances, Spot instances, based on your job requirements. It simplifies execution of complex batch jobs by handling scheduling, scaling, and resource management for you. So in the exam, watch out for those key phrases where you know that you're going to be selecting AWS Batch. Lambda is serverless compute capability, so it basically executes code based on a trigger or an invocation. So your code can be written in any language, Java, Python, whatever it might be. And then you basically trigger that particular function or that execution of that function using some other service, like call through a website, or maybe an upload to an S3 bucket or an event bridge rule, etc. You're charged on a pay-as-you-go model. You actually get 1 million requests as part of free tier. It's what is known as event-driven execution. So it integrates with S3 DynamoDB API gateway to respond to events in real time. There's an execution limit of a maximum runtime of 15 minutes per invocation. So it's not ideal for every use case. You need to see exactly what the use case is. If the execution of a particular piece of code or the processing of a particular feature of your application is going to take longer than 15 minutes, then probably Lambda is not the best choice. It does have certain resource limits. The memory is capped at 10 gigs with proportional CPU and a temp storage of 512 MB. But I do want you to remember the maximum runtime of 15 minutes per invocation for the exam. Okay, so that's Lambda for you. You could actually build complete end-to-end serverless applications with the help of things like Lambda, DynamoDB, Amazon S3, rather than making use of servers and having to manage your EC2 instances, which adds to the administrative burden for your applications. So in fact, I do have a lab exercise, a walkthrough on the YouTube channel. So there's a link for the YouTube channel there. Feel free to give that a try. You can actually build this entire lab in your own AWS account, which makes use of Athena, Lambda, Event Bridge, and gives you some hands-on practice as well for real-world use cases. So check that out in your spare time, please. Let's talk about containers next. So with containers, you have standard, before containers, you've got applications or virtual servers or VMs. Your EC2 instances are basically VMs that are operating in a standard virtual environment, virtualization environment. They run on hypervisors. And what it basically means is that you have each VM that has a guest operating system along with any shared libraries and then any applications that you might have on that. With containerized application, it changes slightly. With containerization, what you're doing is you're packaging the application and any of its dependencies and libraries and everything else that it needs to function as a container that then runs on a shared operating system. Okay, so each VM has its own operating system, guest operating system. So your EC2 instances will have Linux, Windows, whatever it might be. But with containers, each application is stored as a container and deployed as a container on a shared operating system. So it's a lot more versatile, it's a lot more lighter and easier to manage, and comes with a lot of benefits of performance capabilities as well. Now, the reason why containers might be a better option is also because of things like compatibility issues. When you host multiple applications on a given server, you're making use of shared libraries. Okay, so what happens there is, let's say, for instance, you have an application that needs a particular version of Node.js, okay, or a particular version of Python. Now, what happens is if you have another application that you need to run on the same server, on the same physical hardware, but it needs a different version of that same service, we've got some compatibility problems then, and you may need to manage that better. Creates a lot of overhead for you as a customer. So with containerization, that's taken away because each application has its own set of tools, libraries, and utilities and frameworks bundled as part of that container. And now you don't need to worry about those compatibility issues. Furthermore, all of these different containers share the same underlying kernel of the operating system. So the good thing about that is you don't have that bloat that comes with having to have each VM having its own guest operating system. So those are the benefits of using containerization. On AWS, we have ECS and EKS. So ECS makes use of, is known as Elastic Container Services. And it also allows you to store all of your container images in a repository called ECR, Elastic Container Registry. So in the exam, if you see any question related to where are container images stored on AWS, well, ECR is the answer. Which service offers containerization? ECS does. Which service offers Kubernetes orchestration for your containerization? EKS does. We'll talk about that in a second. So the idea is that you store your container images or your Docker images in ECR. You then deploy them to the ECS container service. And you've got two different launch types there as well. You've got the EC2 launch type, which is a server-based, ideal for long-running workloads. And this is where actual EC2 instances are provisioned to host your containers. And you can see those instances and manage them. Or you can go with the serverless option, which is a Fargate launch type. You're likely to see a question related to the Fargate launch type, so watch out for that. That's ideal for unpredictable short-running workloads, but it's where AWS manages the underlying servers for you, and you just need to provision the ECS cluster and the ECS task definition, etc., in order to provision your ECS containers. EKS, as I mentioned very briefly a moment ago, is a service that helps you use Kubernetes to manage all of your containerization. So Kubernetes is a tool to help manage and organize apps to run in containers. And it automates tasks like starting apps, scaling them down, fixing issues, etc. EKS is managed Kubernetes service on AWS and allows you to run Kubernetes on AWS or even on premises. AWS Backup is a managed service that helps you automate and centralize backups for your data across various services like EC2, RDS, DynamoDB, EFS. So each of these services, you can individually create your own backup definitions and backup strategies, but you can use AWS Backup to centrally manage all of that for you. Okay, so things like backup, setting up the backup schedules, what are the retention policies, any compliance requirements, all in one place. Elastic Beanstalk, right at the beginning, we spoke about PaaS, right? We spoke about the fact that platform as a service is a service that you need to be aware of, allowing you to deploy your applications and allowing AWS to provision all of the underlying infrastructure to host that application. Well, Elastic Beanstalk provisions the core infrastructure and the environments in the following platforms and services. And this is just a short list of a much bigger list. So, if your platforms and languages are Tomcat, Java, Apache HTTPS for your PHP and Python, Nginx, .NET Core and .NET for Windows, Go, Ruby, others, etc. So all of these different services or platforms and languages can be used to deploy applications on Elastic Beanstalk. What I want you to remember about Elastic Beanstalk for the exam is that it is a platform as a service tool that allows developers to deploy their applications on AWS, where AWS provisions all of the underlying infrastructure required to host your application. Okay, that's critical for the exam. Amazon Lightsail. Now, Amazon Lightsail can be thought of as a virtual private server. So it's not exactly EC2. Instead, what it is, it's a virtual server with pre-configured Windows and Linux application stacks and an intuitive management console to provision them. So if you want to deploy a single or a couple of WordPress servers, you could deploy some EC2 instances, install WordPress, configure EFS for the file sharing and all of that stuff and do all of that manually. Or you can go with Lightsail. And Lightsail can be quickly deployed, comes pre-configured with the WordPress application and all of the necessary services and tools to get you up and running. Obviously, Lightsail is a bit more cut down version of a larger configuration. So with Lightsail, you think about more simple setups, more simpler deployments. Whereas if you have more complex deployments with auto-scaling management and all of those different variations and combinations of configuration items that you need to define, that's when you use EC2. Otherwise, Lightsail can quite effectively fit the bill depending on the use case. So you focus on the code, not the bill, because Lightsail bundles all of the resources you need into a single simple price, and it automatically configures network access, security environments, taking the guesswork out of launching your own server. Okay, so in the exam, if you see things like questions around, you want to deploy a quick server to host a WordPress application without the overhead of managing complex environments, Lightsail is probably going to be the answer to go for that. Okay, so that pretty much covers the compute section of this revision course. So we had a look at EC2. For the EC2, I want you to remember about the different pricing options. I want you to remember what is an AMI. I want you to remember about the fact that it's deployed in an availability zone rather than in a specific region, because it's zone specific. You must know the differences between EBS and instance store, what an EBS volume is. You must know about things like, the different types of compute services that we have. So we have Lambda for serverless compute invocation. You've got ECS for containerization. You also have, we just looked at Lightsail, Elastic Beanstalk. Those are the different compute services that are available on the AWS platform. Okay, I'm going to bring up the next slide deck. Okay, let's bring up the next slide deck. Just bear with me. So we're going to take a look at databases next. Okay, so with databases, you've got two options to deploy your databases when it comes to relational databases. Okay, you can either deploy and install. You can either install your databases on an EC2 instance, so you can get, Oracle, or you can get MySQL, Microsoft SQL, and install it on an EC2 instance. That is a possibility. Problem with that is you're going to have to do all of the management of those servers yourself. Scaling, high availability, backups, OS patching, antivirus licensing is all down to you. Plus, you have to optimize your application to access the database. Or you can use the Amazon RDS service, which is a managed database offering for relational databases across several different engines, where AWS takes care of all of that for you. You need to configure them, or you need to enable those services. So if you want storage scaling, if you want high availability, if you want database backups, you need to select those options. But then AWS takes care of it, of actually doing the various scaling and the backups, etc., for you. And they'll patch the databases, manage the licensing for you. And all you then need to focus on is the application optimization. So those are the two ways of deploying databases. Obviously, RDS takes away a lot of the overhead from you. But the thing with that, obviously, then is that you don't have granular access to the underlying operating system on standard RDS environments. Maybe you need to configure that in a particular way. Now, there's another product called RDS Custom that gives you that level of access, the access to the underlying operating system. If there is some strange custom configuration that you need to do in order to support a particular database, so you can do that. But that's a fairly new product. That's called RDS Custom. Otherwise, standard Amazon RDS doesn't give you access to the underlying operating system or the actual software that is managing that database. You've got an interface in which to configure your database, enable scaling or make sure you configure backups, etc. But the bulk of the administrative task at the database layer is managed by AWS. There are a number of engines. You've got Aurora, which is actually a MySQL, PostgreSQL compatible database. You've got Postgre, you've got MySQL, MariaDB, Oracle, SQL Server, and you've also got now IBM DB2 available as the engines as part of the RDS offering. And if we take a look at a quick diagram over here, the idea is that with RDS, obviously your users are going to come in to access your web application. The web application is then going to be configured to access the backend database. Okay. And we have different features of the database to offer high availability and resilience as well. So for example, you can configure your RDS with something called multi-AZ. So multi-AZ basically where you have a standard primary copy of your instance. So your users connect to the primary copy, okay, so that they can write to the database and read from the database. There is a standby instance configured in a multi-AZ deployment where you have synchronous replication of all of the data to the primary being copied to the standby. The problem, or rather the purpose of this, is that if the primary database fails, the secondary standby copy gets promoted to become the new primary, and it can then continue operations. So you don't have a major outage. There's also something called an Amazon multi-AZ DB cluster. Now, this is slightly different. This is where you've got two copies of your primary database. So you've got a primary writer database, but then you've got two reader copies. So these actually can be read from whilst the replication is happening. In a standard multi-AZ deployment, your read and write access happens against the primary database. You cannot actually read from the standby. It is literally there as standby, only waiting to be promoted to the primary in the case of a disaster. Whereas with a cluster, a multi-AZ DB cluster, these two secondary copies are actually readable copies. So you can direct read requests to them as well. So that's the key difference here. But what happens is in an outage or in a failure of the primary copy of your database, you want to quickly fail over to the standby copy. And within a matter of minutes, if the primary instance fails, the standby copy gets promoted to become the new primary. Users are redirected to the standby that is now the new primary to continue their read and write operations. So that's how Amazon RDS offers you high availability. We also have read replicas. Read replicas is how Amazon RDS offers you scalability. Because of the way how relational databases work, the default out-of-the-box configuration doesn't give you a ability to have multiple write copies, but you can have multiple read copies. So what this means is that you've got maybe, say, a primary copy, and then you've got a read replica. And those read replicas can be either in the same region or, as the diagram is showing, in a different region. So that's really good, because what it means is that you can have a read replica of your database in the UK, the read replica can be in the US. And so the primary copy is where your clients can both read and write to the database, but bear in mind that the read replica only offers read access, okay? Because the data needs to be asynchronously replicated in one direction. So when it comes to Amazon RDS, you've got multi-AZ for high availability. I want you to remember that for the exam. And you've got read replicas for scalability, okay, to scale out your read queries. And so a lot of applications tend to just read from the database. Some applications need to write to the database as well. Those that only need to read from the database can be pointed to the read replicas alone, okay, rather than adding all of the load on the primary copy. Okay, let's talk about backups and restores. So you've got two different types of backups. You've got automatic backups, which allows you to set a retention period between 0 to 35 days. 0 obviously means that the backup is disabled. 1 to 35 days, so 35 days is the maximum retention period. So every day you can do a backup, and then you can have a maximum of 35 backups. Depending on how you configure your backups, you can determine your RTO and RPO levels. So RTO stands for recovery time objective, the amount of time it takes to recover from failure. RPO is the amount of data an organization is willing to lose in the event of a disaster measured in time. Okay, so if your organization says to you, we cannot afford to lose more than 4 hours of data, that means you need to perform your backups every 4 hours. Okay, so you need to create your manual snapshots to create those, or you need to create a schedule to create your backups every 4 hours, because the maximum amount of data your organization is willing to lose in time is 4 hours. Whereas if your organization says that we can cope with losing 1 day's worth of data, then you only need to perform the backup once a day. That kind of thing. In addition to automatic backups, you can create manual snapshots. Now, manual snapshots are ones that you create, like, for instance, if you're making a major change to the database, or if you are expecting some changes to the application and the way how it works. You should create manual snapshots on a regular basis too, because what it allows you to do is get to a specific point in time of how the data was. So you might argue that why do we need backups when we've got multi-AZ or we've got read replicas? So the reason is, with multi-AZ and read replicas, the data is getting replicated almost instantly across. With multi-AZ is synchronous, with read replicas is asynchronous. But within a matter of seconds, the data is getting replicated across even to the read replicas. What happens if your data is corrupt? What happens if at 3 a.m. this morning, there's corruption of your data? If that data is corrupted, the corrupted data gets replicated as well. So you do need backups as well. You do need to perform regular backups as well, in addition to having multi-AZ and read replicas. Now, the good thing about manual backups is that they can actually be copied across regions. So you can have your backups, say, for instance, of a database in the UK, being replicated across or copied across. Those snapshots can be copied across to the US. If there's an entire regional outage in the UK and all of your data is gone, at least you've got your snapshots in the US. Okay, next, let's talk about another database type, and this is known as DynamoDB. So DynamoDB is a NoSQL database engine, and it supports key value and document data models, and enables developers to develop and build modern serverless applications that can scale and support petabytes of data, offering tens of millions of read-write requests per second, offers high-performance internet-scale applications that would be overburdened traditional relational databases. So what I want you to take away from DynamoDB for the exam, for the Cloud Practitioner exam, is that it's a NoSQL database, supports key value and document data models, supports serverless application design and deployments, okay, and can handle tens of millions of read writes per second, gives you single-digit millisecond latency access to the data. Let's talk about some other databases. There's Amazon Neptune. You might see a question on the exam asking you for which database would you recommend for a graph-style database structure. Amazon Neptune is a fully managed graph database. It's designed to help you build complex relationships between the entities that are stored in the database. So things like social media networking, or business analysis between relationships, and use cases that are things like fraud detection, knowledge graphs, network security modeling, that kind of thing. Social network analysis, social media platforms often use graph databases. We've got Elasticache. So Elasticache is not a standard database. It's a caching engine. It's an in-memory caching engine that enhances application performance by providing fast, scalable caching solution for your databases. So quite often you have the same queries being run, the same data that is being retrieved. Those queries can be stored in cache using an in-memory caching engine like Redis or Memcache. They're less expensive than making calls to the actual database, and they improve performance of your web application for those frequently accessed data. They are often used for things like managing session states or product catalog information, reducing database load, and speeding up the response time. Now, you've got two different engines on AWS. Actually, now you have three. You've got Redis, Memcache, that are the two common ones. Okay, so Memcache is for more simple data sets. Redis is for more complex data sets. Okay, but Redis offers things like replication and backups, etc. Memcache can offer you multi-threaded access as well. For the exam, all I want you to remember is that, especially for the Cloud Practitioner exam, is that Elasticache is a service that offers you caching services for your databases, comes with two engines, Redis and Memcache. Okay, let's talk about how we migrate our databases from on-prem to the cloud. So you've got something called the Database Migration Service, or DMS for short. It's a managed service that helps you migrate databases quickly and securely to AWS with minimum downtime, supporting both homogeneous and heterogeneous migrations. What does that mean? Well, the homogeneous migrations refer to migrating similar database engines, so Oracle to Oracle. So if you've got Oracle on-prem and you want to migrate to Oracle on AWS, that's what we call homogeneous migrations. You use the DMS service for that, and it's as simple as it can be. Heterogeneous is where you are making a change in the engine. So you're changing from one engine to another, Oracle to Aurora, or SQL Server to PostgreSQL. That's where the schema needs to be altered as well, because the schema across these database engines are different. And so the schema and the database code transformation may be required. And so for that, you would need something called the AWS Schema Conversions Tool, or SCT. And it's a tool to help migrate databases and heterogeneous migrations. So you use the tool to first convert the schema from one engine to another, and then you perform the actual migration using DMS. Redshift is another service that I want you to be aware of for the exam. For the exam, all you need to remember for the Cloud Practitioner exam is that Redshift is a data warehousing solution. Okay. And it is a fully managed petabyte scale data warehousing service that enables fast querying and analysis of structured and semi-structured data. It's automatically provisions and scales any of the compute resources, allowing you to run analytics workloads without managing infrastructure or configuring clusters. And what I do want you to remember is that, apart from the fact that it's a data warehousing solution, is that it's designed to help analyze data on AWS, or that you host on AWS. So it allows you to analyze your data, and it's what's known as an online analytical processing database, or OLAP database. There's also another feature of Spectrum, slightly different feature, known as Redshift Spectrum. So Redshift Spectrum is a feature of Redshift that allows you to query and analyze data directly in S3 without needing to load it into the Redshift data warehouse, enabling seamless access to exabytes of data stored in S3. There is another service that does that too, which is Athena. So it's a bit confusing, this one, and I want you to be very careful here. So Redshift Spectrum is tightly integrated with Redshift. It basically works as an extension of Redshift, allowing you to query data in S3 alongside data stored in your Redshift data warehouse. So it's ideal for combining frequently accessed data in Redshift with large amounts of historical data, or maybe infrequently accessed data in S3. And it requires an active Redshift cluster as the compute engine. Whereas Athena is designed to give you a standalone serverless service to query data that is held in S3 without needing a Redshift cluster. So it's best for ad hoc, on-demand data analysis directly in S3 data for querying semi-structured data, JSON, Parquet, OCR, ORC, etc. There's no need to set up any kind of cluster or management. You basically pay for the number of queries you run. So which option do you choose? So you choose Redshift Spectrum if you're already using Redshift and you need to query S3 data as part of a larger data warehouse solution. Use Athena for quick, cost-effective serverless querying of S3 data without requiring a data warehousing solution. Okay, so that's databases for you. I'll bring up the next slide. Okay. So next I want to talk to you about some application integration services. These are going to show up in the exam, so you want to definitely be aware of these. So if you're taking the Cloud Practitioner exam, there are some key services that you need to be aware of. When you're building any kind of solution on AWS, you want to make sure that you have a microservices architecture or a decoupled architecture, a distributed system. You don't want to be building monolithic structures where you have single point of failures. So let's take a look at the different application integration services that can help you achieve that. Okay, let's talk about SNS first. So SNS is a simple notification service. It's a fully managed messaging service. It's what's known as a push-based messaging service, where you have a publisher pushing messages to subscribers. Okay, so it is standard pub/sub model, and it's where you can have a single publisher publish message to a topic, subscribers subscribe to that topic, and any messages sent out to that topic gets automatically pushed out to those subscribers. Your subscribers could be Lambda functions, so triggering Lambda functions, SQS queues, we'll come on to SQS in a second, any HTTP endpoints, email addresses. So if you want to send out email alerts, someone deleted a file from my S3 bucket, let's alert the administrator, right? Something like that is a good example, or even SNS. SQS is another type of integration service that allows you to decouple your architecture. So you can decouple your front end from your back end by having an SQS queue in the middle. So this is a queuing system, a message queuing system that allows you to manage requests coming in from the front end and being processed by the back end. So if you imagine that you have an e-commerce website, you've got a front end and a back end, you're likely to be in a situation where the front end is getting lots of requests, but the back end is not able to cope with those requests at the rate at which it's coming in. In such cases, you can have a queuing system where the messages or the requests can be held in a queue for a duration of time, and the back end can go and retrieve those messages or those requests and then process them as per capacity availability. So that's where something like an SQS queue comes very handy. So in this example, what we're showing basically is that we've got a single fleet of servers managing both the front end and the back end. Okay, if we're getting a lot of requests coming in, we're going to overburden our resources. Instead, if we separate out our web tier from our app tier by having a queuing system in the middle, we can hold messages in the queue. And the default duration for holding messages in the queue is 4 days, but it can be extended up to 14 days. So these are good ways of actually decoupling your architecture, having a more distributed microservices style architecture rather than having everything bundled up as a monolithic structure. And the queuing system can help you manage your workflow much better. Now, when it comes to SQS, there are two types of queues that you can configure. I want you to remember this one for the exam. So you've got standard queues where you've got unlimited number of transactions, at least once delivery, but the message order is not guaranteed. Okay, so these can handle lots of transactions per second, but the message order is not guaranteed. So your application needs to be aware of that, needs to be intelligent to cope with that. You could use some sequencing numbers in your application headers or whatever, and in your message headers or whatever it might be. FIFO queues stands for first in, first out. And so this basically is where the order of the message is preserved. It gives you exactly once processing, and it can support up to 300 messages per second without batching, or 3,000 with batching, because you can have up to 10 batches at a time. So that's just something to be aware of when it comes to SQS. You've got two different types of queues, standard and FIFO queues. Amazon MQ is another messaging service, and it's mostly designed for decoupling application components using open source message brokers like ActiveMQ and RabbitMQ, providing compatibility with industry standard APIs and protocols for seamless integration. So if you're currently using an external third-party message brokering service and you want to port across to AWS, you don't want to change your architecture to use SQS, you can use Amazon MQ instead if you're using one of the compatible components, open source message brokers like ActiveMQ or RabbitMQ. Step functions is another integration service that allows you to basically orchestrate and automate workflows by coordinating multiple services and tasks into your serverless workflows. So step functions allow you to define more visually how the different components of your application is going to be provisioned or used in order to basically allow that workflow to take place. So here we're having basically, a Lambda function that is invoked when we want to perform a check on a stock price. It generates a buy sell recommendation is the next invocation. There's a human approval process that can be involved as part of your step function. So that's an SQS message that's being sent across. And then the choice state, whether it's buy or sell, that is chosen. And then depending on the choice that is made, a different Lambda function is being invoked. Okay, so you can build your serverless workflows calling different Lambda functions, different services as you perform these workflows and build all of this up using step functions. That's pretty much all you need to know for the Cloud Practitioner exam. EventBridge. EventBridge is another serverless event bus service that allows applications to communicate by routing events from one service, such as a SaaS-based application, to targets like a Lambda function or an SQS queue or a step function, enabling these sort of event-driven architectures. So EventBridge can help you schedule actions as well. So the good thing about EventBridge is that it can help you build a workflow, or rather a process of triggering an action based on certain events or on a particular schedule. So a typical example is someone uploads a file to an S3 bucket and you need to process that file in some way. You can create an event generation for that, and that can be basically used to trigger a Lambda function to go and process that file. Or you can create an event so that at 5 p.m. every day, a Lambda function is invoked to go and shut down all of the test servers. So that's where EventBridge comes handy. So I want to quickly show you this Lambda architecture. This is basically a solution that is demonstrated on another YouTube video. And you can click the link over here to get access to that YouTube video. And basically what it does is it shows you how to make use of these different services to build a typical use case example. So here we're using a monitoring application to upload a CSV file to an S3 bucket. When the file is uploaded to an S3 bucket, we've got a Lambda function that is triggered at a particular schedule at 5 p.m. So at 5 p.m., EventBridge triggers a Lambda function. This Lambda function basically captures the current date and path for this file that is uploaded to an S3 bucket, and then calls an Amazon Athena service to basically perform some querying and some analysis on that data, which is then stored in a process subfolder in that bucket. Okay, so the workflow is that at regular intervals, a file gets uploaded to an S3 bucket. At a particular schedule, a Lambda function is invoked. That Lambda function performs or basically integrates with Athena to perform some querying, and the results of that is stored in a particular process folder. So if you want to watch the video and learn how to set this up yourself and get some hands-on experience, click on the link below where it will show you a full demonstration along with all of the source code necessary for you to set this up in your own AWS account. Okay, so that pretty much brings us to the end of application integration services. So what we'll do is we'll take a quick 5-minute break, let you grab some tea, coffee, and just get a breather, and then we'll continue from where we left off. Okay, so we'll continue from where we left off. Welcome back. Let's take a look at analytics next. So there are certain services on the AWS Cloud Practitioner exam that you need to be aware of in terms of the analytics section. So we'll start off by taking a look at Kinesis. So Kinesis is one of the core topics that you will see in the exam. Now, Kinesis is basically a streaming service, and there are 4 different variations of this service. There's the Kinesis data stream, which is real-time streaming. Enables you to collect, processing, and analyze large volumes of data in milliseconds, making it ideal for applications like analytics, ML, and real-time dashboards. You've got Kinesis Data Firehose, which is near real-time streaming data delivery. So this is where I want you to be really careful on the exam, okay? So streaming services, Kinesis data streams is, for analyzing and streaming large volumes of data in milliseconds. But the data firehose is for automatically capturing, transforming, and loading data into destinations like S3, Redshift, OpenSearch, and third-party tools. And that is what it's for. So data firehose is for loading your data into these external platforms or AWS platforms, whereas data stream allows you to actually run compute services against the data, against the stream, analyze the stream, and then provide the results of that somewhere else. Okay, data firehose is just for loading data. Data analytics processes and analyzes streaming data in real time using SQL or Apache Flink, helping you gain actionable insights and build real-time applications. So what happens is, as the data is being loaded, SQL queries are being run against the data in order to perform some form of analytics against it. And then you've got Kinesis video streams to stream and store and process video, audio, and other time-encoded data for real-time and batch analysis, machine learning, and playback applications. Okay, so 4 different Kinesis services on the AWS platform. Glue. Glue is another product that you want to be aware of for the exam. It's a fully managed data integration service for discovering, preparing, and combining data from various sources. The key word here is extract, transform, load. So it performs tasks such as ETL operations against your data, which you can then use and analyze and process with your other applications. We spoke about Athena earlier. So Athena can actually make use of Glue to discover the schema of your data, to extract the schema of your data, to understand what your data is all about. Okay, so with Athena is basically used to look at your data and to analyze your data and run SQL queries against your data held directly in S3. But Athena needs to understand the structure of that data or the schema of that data. And here you can employ a Glue to perform a crawl exercise against that data to discover that schema for you. QuickSight. Now, on the exam, QuickSight is a really simple question to answer. Basically, any service that is looking for business intelligence, that is wanting you to create business intelligent dashboards or reporting services, share interactive dashboards and insights from your data with features like machine learning powered analytics or natural language querying, QuickSight is the one that you want to select in those answer options. Okay, so you got Glue, right? You got you got Athena, you got Glue, and you've got QuickSight. Okay, so those are the different application analytics services. Let me just quickly bring up the next slide. Can you just bear with me? Okay, we'll take a look at some security services next that you need to be aware of for the exam. Okay, so let's take a look at some security services So with security services, we've got different sets of security services that you want to be aware of. Let's talk about encryption first. So you've got KMS. Now, KMS is a fully managed service that allows you to create, store, and manage your encryption keys for securing your data, providing personalized control over encryption across AWS services and application. KMS is a service that will help you create your customer master keys and use that to define what are called data encryption keys that can then be used to encrypt and decrypt data. KMS with KMS, you can either use the AWS provided keys, or you can create your own customer master keys and use that to create all of your encryption services. Okay. You then have Cloud HSM. So the key difference between Cloud HSM and KMS is that Cloud HSM, it's a fully managed hardware security model that allows you to generate and use your own encryption keys for securing data with hardware level security. So with KMS, when you're creating your keys and managing your keys, you got to remember that the keys are stored on shared hardware security models, which means other customers have access to the same hardware. Now, that may be a problem from a compliance and regulatory perspective, depending on what industry you work in. Okay, it may be stipulated that for your organization, you need to have your own fully managed hardware security models dedicated to your organization. That's where Cloud HSM comes into play. And so you want to be using Cloud HSM there. So watch out for the question, see how it's phrased, and you might have to choose Cloud HSM instead. The thing about Cloud HSM is that if there's a problem with the hardware security model and you lose your keys, well, then you're stuck. So you usually would deploy at least a couple of HSMs, Cloud HSMs devices in your for your organization so that you've got some form of failover option as well. Next, I want to talk to you about GuardDuty. This is an intelligent threat detection service that monitors malicious activities and unauthorized behavior patterns across your AWS account. It will analyze events from things like the CloudTrail management events, okay, things like AWS user and API activity, CloudTrail data events, VPC flow logs, which we mentioned a little bit earlier in the networking section, DNS queries and name query patterns. It will take all of those events, run ML and analytics on it, and then detect things like reconnaissance, instance compromise, account compromise, bucket compromise, etc., and produce for you or integrate for you with CloudWatch to ultimately send out things like alerts using Amazon SNS, which is an alerting service, or even call Lambda functions to perform certain automated remediation actions. Okay, so Amazon GuardDuty is a intelligent threat detection service that allows you to monitor malicious activity, unauthorized behavior, and then take action against them, okay, and detect them for various compromises that might happen in your AWS account, and then integrate with CloudWatch to call Lambda functions or run SNS, send out alerts, etc. So just remember, intelligent threat detection service, GuardDuty. Okay. Next, I want to talk to you about is Detective. Now, Detective helps you to analyze, investigate, and quickly identify the root cause of potential security and suspicious activities. So GuardDuty will identify and help you monitor those malicious activities, but Detective will help you work with identifying the root cause of potential security issues or suspicious activities. So using the data in VPC flow logs, Amazon Macie, Security Hub, GuardDuty. So it uses the data from GuardDuty to ultimately analyze the findings, collecting and combining logs, using ETL tools and scripting to perform deep dive investigation. And that's where GuardDuty shines and comes into play and gives you a report about what that root cause would have been for that malicious activity. Okay, so that's one that you want to remember for the exam. So GuardDuty will help you drill down into relevant historical activities and quickly determine the root cause of those attacks. Inspector is another tool I want you to remember for the exam. Now, Inspector is a vulnerability management service that automatically discovers workloads and continuously scans them from software vulnerabilities and unintended network exposure. Just remember that Inspector is a service designed to help you perform vulnerability analysis and management for your EC2 instances. Okay, so it centrally manages multiple AWS accounts. You can do that. You can continuously scan your environment for vulnerabilities and network exposure. So common vulnerabilities and exposures, CVE, network open ports, what ports are open. And the inspector CIS scans is a benchmark for your EC2 instance operating system to make sure you configure them in accordance with best practices and established by the Center of Internet Security. And so that is something to be aware of. So basically, to use inspector, just a little bit more additional information. The default configuration allows you to just see what ports are open, what network ports are open. But if you install the inspector agent on your EC2 instances, you can perform the vulnerability and exposure scans as well. And obviously deep dive a bit more into the vulnerabilities that are on your EC2 instances. Okay, so this is really critical. So AWS Inspector allows you to achieve that. Next, I want to talk to you about Amazon Macie. Now, this is a security service that helps you detect risks in your S3 environment against things like personal identifiable information, personal healthcare information. It can scan S3 buckets and provide dashboard and alerting services, and gives you an interactive map to help you guide your decisions to perform deeper investigations on specific S3 buckets by running targeted sensitive data discovery jobs. So it will run targeted sensitive data discovery jobs to help you meet regulatory requirements like HIPAA compliance or GDPR against data held in S3. Any data that's held in S3 that may have personally identifiable information, social security numbers, NI numbers, or anything like that, or driver's licenses, all of those things that can personally identify a person can be detected by Amazon Macie. And then you can create a dashboard or alerting mechanism to alert you of how that data is being manipulated or used or moved around your S3 buckets. Amazon WAF, Web Application Firewall, lets you monitor HTTPS requests that are forwarded to your protected web resources. Resources like CloudFront distribution, API gateways, your application load balancers. WAF integrates with all of those services to help you protect and control bot traffic or block common exploits like SQL injections, cross-site scripting. It also offers a service to run capture and challenge checks against requests that match your criteria. So you can implement capture and silent challenge controls against requests to help you reduce bot traffic to your protected resources. We've also got Shield. So whereas WAF is a web application firewall at the application layer, Shield is a network protection firewall offering distributed denial of service protection that safeguards your web applications running on AWS. Shield provides you with an always-on detection and automatic inline mitigations that minimizes application downtime and latency. So you've got two different variations or options for the service. You've got the Shield Standard, which gives you the most common frequently occurring network transport layer DDoS attack prevention. It integrates with things like CloudFront and Route 53 and gives you protection against layer 3 and layer 4 attacks. Shield Advance gives you protection for anywhere in the world by deploying CloudFront in front of your application, where your origin server may be an S3 bucket, an EC2 instance, an elastic load balancer, or even custom service outside of AWS. And also with Shield Advance, you have access to the the Shield Advance to the response team, and they can help in any mitigating any sort of attacks that may be taking place as well. Okay, so that covers the core security services that I want you to remember for the exam, and I want you to study for the Cloud Practitioner exam. Let me bring up the next slide deck. Okay, there are several management and governance tools that I want you to be aware of for the Cloud Practitioner exam. So let's take a look at that next. So the first one is CloudFormation. So CloudFormation is an infrastructure as code tool. It allows you to build and deploy your infrastructure, whether that's a VPC, EC2 instances, databases, load balancers, whatever it might be, S3 buckets, using code. So you use either YAML or JSON code, and you script out your actual deployment, and then you use CloudFormation to follow that code to provision your infrastructure resources. The benefits of it is that you can have consistent, repeatable deployments without any margin for error, because you have got everything written down and scripted out as code. Okay, if you're using mouse clicks, if you're using manual configuration and creation of all of these resources, you're bound to have lots of variations from one environment to another. CloudFormation prevents that. CloudFormation speeds up the entire process for deployment. If you're going to deploy a complete 3-tier architecture stack with a VPC and an EC2 set of services, auto-scaling, databases, everything, might take you half a day to set it up. CloudFormation, you'll be up and done in minutes. There's also another product that we spoke about earlier, which is Elastic Beanstalk. And I want you to be aware of the key differences between CloudFormation and Elastic Beanstalk. So CloudFormation focuses on automating infrastructure provisioning using IAC, infrastructure as code. Elastic Beanstalk simplifies the deployment and managing of the application by automatically handling the underlying infrastructure. In actual fact, what is happening, Elastic Beanstalk is using CloudFormation to provision that infrastructure for you. Okay, so you got Elastic Beanstalk, which is the platform as a service tool. You upload your code in a supported language along with any additional pieces of information to Elastic Beanstalk. You tell Elastic Beanstalk that you want a VPC, you want high availability, you want a database, you want auto-scaling, and Elastic Beanstalk provisions the environment for you. But it uses CloudFormation to do so. CloudFormation is the actual tool that provisions that infrastructure for you. Elastic Beanstalk, therefore, is designed for the developer that's focused on one specific application stack that needs to be configured. CloudFormation is your opportunity to build a core infrastructure that can support n number of applications. Or you may choose to deploy multiple CloudFormation stacks for different sets of applications. Okay, so Elastic Beanstalk is focused on one application. CloudFormation is focused on the infrastructure. But Elastic Beanstalk uses CloudFormation to build that infrastructure to support the application. Okay, so let's talk about CloudWatch. So CloudWatch is a monitoring tool, an observability tool that provides actionable insights by collecting, analyzing, and visualizing metrics, logs, and events from your AWS resources, on-premise systems, and applications. So your EC2 instances, what's the CPU utilization like? Your load balances, what are the requests coming in like? Is there too many requests coming in? Your Lambda functions, how many functions are being invocated? Your load balances and your target groups, how many healthy hosts are in your load balancer targets, the target group. So all of those pieces of information is stored and managed in CloudWatch. And CloudWatch allows you to collect all of these metrics, and then you can use these metrics to perform various actions as well. So you can run various alarms, you can create alarms. These alarms can trigger, say, a Lambda function, or they can be used to send you out an alert, etc., trigger an auto-scaling action, etc. So CloudWatch is a versatile tool for managing the health of your resources on the AWS platform by allowing you to monitor all of the metrics reported by these various resources. CloudTrail. Now, CloudTrail is a governance tool, and it allows you to audit and monitor basically all of the API activity that happens in your AWS account. When you log into your AWS account, that's CloudTrail recording that you've logged into your AWS account, which IP you logged in from, what time of day you logged in, what user ID did you use to log in. All of that information is stored in CloudTrail, and you can create additional trails and more global trails to basically analyze and store audit information about what's happening in your AWS account. My friend Bob decided to launch an EC2 instance at 10 a.m. last night in the US East 1 region. That information is stored in CloudWatch as an audit log. And so using CloudTrail, you can actually see a detailed history of all of the API calls and actions taken in your AWS account against your AWS resources. Config. Config is a monitoring tool that evaluates and records the configuration of AWS resources, enabling you to make compliance, security analysis, and resource change tracking. So you can use it to continuously record configuration details of AWS resources, provide historical view of tracking changes, and then using that to troubleshoot any issues. It also allows you to therefore fulfill any compliance or auditing requirements for those configuration changes. Those configuration changes that have taken place, are they aligned with corporate policy? And do they meet regulatory standards? It also helps with change management and notification. So it can detect and notify you of configuration changes, enabling quick actions on unauthorized modifications or misconfigurations. So that's where config comes into play. And if you see anything related to change management or things like monitoring changes to your resources, config is probably the answer to select in the exam question. Let's talk about AWS Organization very quickly. We've mentioned this right at the start. AWS Organization helps you manage multiple AWS accounts in a single organization setup. And what that means is that you can have multiple accounts all managed by your organization management account. With AWS Organization, we've got the Richard Rose Limited and the AWS Organization for Richard Rose. We've got two accounts here, the dev account and the prod account. We can create what are called OUs, organization units, and we can have multiple dev accounts in the dev OU, multiple prod accounts in the prod OU. Well, what this means is that we can apply service control policies to enforce certain rules and restrictions on those accounts. So we can say, for instance, that these accounts are not permitted to use DynamoDB, or the dev account is permitted to only use S3 and RDS and that kind of thing. So you can use service control policies to restrict what happens in those accounts, and then subsequently IAM policies or resource policies within the accounts about who's got access to what. So both work in tandem with each other. But the good thing about AWS Organizations is that it helps you also benefit from something called consolidated billing. So whereas if these two accounts are separate and external to each other, rather than part of an organization, each account has to manage its own billing. As part of an organization, you can use the consolidated billing feature to get a single bill for all of your accounts, but also benefit from things like volume discounts across the accounts. So if you're consuming X number of units of a particular service in dev account and Y number of units in the prod account, and if the total exceeds a particular threshold where you start to benefit from per item discounts, then putting them as part of an organization can be a cost benefit for you as well. Let's talk about System Manager. System Manager is another service that you want to be aware of for the AWS Cloud Practitioner exam. Now, there are several tools in System Manager, and it's more for governance and managing your AWS resources. So we've got a tool called the Patch Manager, which automates the process of patch operating systems and applications across your hybrid infrastructure, ensuring compliance and security at scale. So you can use the Patch Manager for all of your patching needs. Parameter Store allows you to store scalable services for storing and managing configuration data and sensitive information like passwords, API keys. Session Manager provides secure and auditable SSH and RDP-free access to your EC2 instances and on-premise service for remote management and troubleshooting without the need to open inbound ports. So instead of having bastion hosts that you connect to from the outside world, and then from there you jump into backend EC2 instances, and you have to open SSH ports and use SSH clients, well, instead of that, you can use Session Manager, which is a lot more secure method of accessing your resources and private subnets of your VPC. Service Catalog is a service that allows organizations to create and manage and distribute catalogs of approved AWS resources and applications, enabling consistent and compliant provisioning of infrastructure and service across teams. And there's one more service that I want to tell you about, and that is the Secrets Manager. So Parameter Store is a service that allows you to store parameter data or sensitive data that can then be retrieved by your application. So environmental variables is a good example of parameter store, or API keys. But sometimes you want to perform things like, with additional security, you want to use tools like the ability to be able to rotate those keys. So say, take database credentials, for example. So with database credentials, you don't want to hard code them in your application code. You can either store them in parameter store and have your application retrieve them dynamically when required. But there's another service called Secrets Manager that allows you to store those same credentials for your databases. It offers an additional feature, which is called rotation. It allows you to rotate your keys at regular intervals, every 5 days, 7 days. And so you can rotate those database credentials on a regular basis, which means in the same way as you rotate your passwords, your database credentials can get rotated as well, enhancing the security factor. Okay, so that pretty much covers a number of our core management and governance tools. Let me bring up the next slide deck. Okay, so next there are some machine learning services that you need to be aware of. In fact, there's a whole host of different machine learning services that you really should know about. I'm just going to cover some of the more common ones in this session. So we've got Amazon Recognition. Amazon Recognition is an ML service that allows you to analyze images and videos using ML to detect objects, scenes, faces, text, activities, as well as perform facial recognition and sentiment analysis. Another tool that you should be aware of is Amazon Poly, which converts text to lifelike speech, enabling you to create applications with natural sounding voice interactions and in multiple languages and voices. We also got something called Amazon Personalize, which allows developers to build real-time personalized recommendation systems for application websites and marketing campaigns using user data to deliver tailored content and experiences. There is Amazon Comprehend, which is a natural language processing NLP service that uses machine learning to analyze and understand text, extracting insights such as sentiment, entities, key phrases, languages, and relationship within the content. Lex for building conversational interfaces using voice and text, enabling developers to create things like chatbots, virtual assistants powered by natural language processing, automatic speech recognition, and SageMaker, which is a fully managed service that provides developers and data scientists with the ability to build, train, and develop and deploy machine learning models at scale with integrated capabilities for data prep, model tuning, and real-time inference. We've also got another tool called Textract, which is an ML service that automatically extracts text, handwritten layout elements, and data for scanned documents. It goes beyond simple OCR to identify and understand and extract specific data from documents. Transcribe for automatic speech recognition service provided by AWS that converts spoken language to written text. So it allows developers to add speech to text capabilities in the application by analyzing audio files and producing accurate, readable transcripts. And Translate, which is a neural machine translation service by AWS to automatically translate text between supported languages, uses advanced deep learning models to deliver fast, high-quality, accurate language translation, making it ideal for real-time communication, website localization, and multilingual content generation. Okay, so those are some of the core ML services that you want to remember for the exam. Again, you're going to get scenario-based questions, very short, simple, direct questions where you need to select which service would be ideal. So, if you're doing image recognition, then, recognition is the service. If you are trying to extract text from a PDF document, Textract will help you achieve that. If you're transcribing, some sort of audio file to text, Transcribe is going to work and help you achieve that kind of thing. Okay. Okay, so I want to quickly take you through billing and pricing next. So let's do billing and pricing. So we've got the AWS Billing Conductor, which is a managed service that can support the showback and chargeback workflows of solution providers and enterprise customers. It models billing relationships between you and your customers or business units. You can customize a pro forma version of your billing data each month to accurately show and charge back to your customers. You can think of it as a custom invoice generator. It allows you to group accounts or services and apply custom pricing or discount based on how you want to allocate costs. And you can create custom billing views to better understand and report on costs. Help with cost allocation for internal teams or customers, makes it easy to track and charge back cost on specific project or clients, and managing budgets and forecasting. That's the Billing Conductor. You want to remember that for the exam. We've got Cost Explorer, which allows you to visualize your cost over a period of time. It actually allows you to extract your cost for the current month and the last 12 months, and then also forecast potential cost for the next 12 months based on your usage pattern. The current month's data is available for viewing in about 24 hours once you enable it, and the rest of your data can take a few days. But Cost Explorer updates your cost data every 24 hours. So what you can do is you can define the report parameters for what you want the date range to be. So here I wanted it from June 24 to March 25, going into the future, and it tells me what my potential cost is going to be in the future. Budgets allow you to set custom budgets for various reasons. So you may do so like a monthly budget, or you may set up a custom budget for a particular project where you want to get alerted if we're exceeding any thresholds of that budget. Okay, so you can use budgets to also set RI utilization and coverage costs. So RI is reserve instances, and receive alerts when your utilization drops below a particular threshold that you define. And budget alerts can be sent via email or SNS, or to a specific SNS topic that then gets triggered out to a specific email, for example. Cost and usage report is a comprehensive tool that provides detailed information about your AWS usage and costs. It's more granular, and it allows you to deep dive into your cost usage patterns for the various resources that you've provisioned in your AWS account, according to organized by accounts, resource tags, and any other dimensions. The data is delivered in CSV format to Amazon S3 bucket that can be included with for analytics with Athena, Cost Explorer, or third-party tools for deeper insights. There's also another product called the AWS Pricing Calculator that allows you to perform analysis of what the potential cost will be for a particular project. So you go into the Pricing Calculator website, and you basically define all of the different resources that you're going to provision for your project, how many instances you need, what version of the operating system it is, what's the instance type you're using, how much storage, data transfer in and out, databases, if you're using any SNS tools or SQS queues, whatever it might be, you define all of that in your pricing calculator, and it gives you an estimate monthly bill for that configuration. So it's very useful and very versatile in your proposals, or just getting an understanding about what the cost is going to be for a specific project. Okay, so that pretty much covers all of our billing and pricing models that I want you to be aware of for the exam. What we're going to do next is I'm going to quickly take you through some practice exam questions, just so that you can get a feel of what that looks like in the real exam. Okay, so let's go ahead and take a look at some practice exam questions. So when you're taking a look at exam questions on the AWS platform, you want to look at some keywords and phrases within the exam to know exactly how to answer that question. Okay, most of the exam questions in Cloud Practitioner exam is going to be fairly simple and straightforward. There may be one or two scenario-based questions, but it's not going to be too complex or heavy. Regardless, you need to understand exactly what the question is about and then be able to select the right answer. So identify keywords, understand the scenario, and eliminate any wrong options is your strategy to answering those exam questions. Remember, you've got 90 minutes on the exam, so that's less than 2 minutes per question. So here's question number 1. So question number 1 says, you must ensure that all IAM users have a complex password configuration with a minimum of 12 characters consisting of capital letters, lowercase letters, numbers, and at least one symbol. Password must expire every 42 days. Which IAM feature should you configure to meet the requirement? So we already know that we're trying to look at password complexity as a key requirement. Okay, and your answer options are password policy, service control policy, IAM policy, and password complexity 2. So you should, by definition, be able to then define which one this is. So let's take a look at all of these questions, these answer options. So we'll start with this one at the bottom, password complexity 2. So there isn't actually a service called password complexity tool. And that's something, therefore, you need to know for the exam. So we can eliminate the IAM policy are policies that you attach to IAM users or IAM roles. They're not password policies. So watch out for that in the exam. So it's not C either. And then we've got service control policies, which are policies that are applied at the account level, as we discussed in the AWS Organizations section earlier. So service control policies allow you to define what services can be allowed in a particular account of an organization. And so the answer is A, password policy. Okay. So if we take a look at that, the correct answer for this one is password policy. Okay, so question number 2. So which AWS service can help you monitor performance metrics of your EC2 instances, such as CPU utilization, and then configure alarms to send out notifications if thresholds are breached? Okay, so your answer options here are CloudWatch, Config, CloudTrail, or Lambda. So let's take a look at the key words here. So you want to monitor performance metrics, things like CPU utilization. The tool that helps you achieve that is going to be CloudWatch. Okay, remember, CloudWatch allows you to monitor performance metrics like CPU utilization, configure alarms. Config allows you to monitor changes in the configuration of your resources and have rules to perform remediation actions or identify misconfigurations. CloudTrail is for monitoring API activity, who logged in when, from which location. And Lambda is a compute service or a serverless compute service that allows you to execute code in response to an event or a trigger. Okay, so that's CloudWatch dashboard there showing you the CPU utilization, for example. Let's take a look at another question. So which AWS service highlights potential security issues and offers recommendation in your AWS account, such as the root user not configured with MFA settings? Okay, so you've got highlighting potential security issues and offering recommendations. The answer is AWS Trusted Advisor. Okay, this service we spoke right at the beginning of this session today allows you to basically see any recommendations that AWS has across 5-6 different categories. Okay, there was performance, fault tolerance, security, cost optimization, service limits, and operation excellence, 6 in total. And it gives you recommendations to ensure that you can meet AWS recommended best practices across all of them. Amazon Macy is not the answer. That allows you to monitor for personally identifiable information held in S3. Service Health Dashboard allows you to see any changes or plan outages that AWS might have, which might affect your resources. And GuardDuty is an intelligent threat detection service. Okay. Question 4. Your front-end developers are building an application that requires sending push-based notifications of a new video upload to an S3 bucket across multiple SQS queues. Which AWS service offers parallel publishing of such notifications on AWS? Okay, so here, let's take a look at the key phrases. This is push-based notification. So when you see push-based notification, immediately you should understand that it's not going to be a pull-based messaging protocol. So it's definitely not SQS. Okay, and it's a push-based notification. So let's just see, and you want to send that notification across multiple SQS queues. It also offers parallel publishing. So it's going to be SNS. Because you're saying you want a push-based notification messaging service, a push-based notification service, SNS provides that for you. Okay, it's not SQS because SQS is a pull-based messaging protocol. It's a message queuing service to allow you to decouple your application stack. Similarly, it's not Kinesis data stream because that's a streaming service, and it's not QuickSight because QuickSight is a business intelligence tool. Okay. All right, let's take a look at the next question. So question 5, which AWS service offers a visual console to help you coordinate the components and steps of your application's various functions and represents its logical workflow. So here we've got steps of your application's various functions. So, we're taking a look at the actual workflow of your application. So as a user comes in, maybe it's an e-commerce application. Okay, if he puts his credit card details in, what happens if it's declined or if it's accepted? So there are different steps to follow and different functions to follow. And so here you've got a logical workflow that you can build. So this AWS service can help you build that logical workflow and give you that visual representation using that visual console. So the answer to that one is step functions. It's definitely not SNS because that's a push-based notification system. It's not Event Bridge because Event Bridge is an event bus system that allows you to create and manage events and use those events to trigger services or resources like Lambda functions or SQS queues. And CloudWatch is definitely not the answer because that's just a monitoring service. Okay, good. Next question is question number 6. Which AWS service enables you to trace and analyze application behavior, making it easy to identify performance bottlenecks? Okay, so we want to trace and analyze application behavior so that we can identify performance bottlenecks. Now, what I want you to remember here is that you're tracing and analyzing application behavior, not network behavior, not EC2 instances. You're not analyzing the EC2 instances. You're not analyzing any of the AWS resources. You're analyzing the application behavior. Okay, and the answer to that one is Amazon X-Ray. So AWS offers a service called Amazon X-Ray, which allows you to analyze the components of your application, the various stages, the various components of your application, and see if there are any bottlenecks somewhere in terms of the way how data is moved from one component of the application to another. It's not WAF, because that's a web application firewall. It's not detective, because that basically allows you to identify the root cause of malicious attacks. And it's not Macy, because Macy allows you to identify personally identifiable information held in Amazon S3. Okay. So this is what a typical segments timeline looks like for an application using Amazon X-Ray. Question 7. Okay, so, question 7. Which AWS services can be used to obtain information about how an EC2 instance in the US East 1 region was terminated? Okay, so the key phrase here is how an EC2 instance in the US East 1 region was terminated. You want to obtain information about that. Okay, so the answer to that one is CloudTrail. CloudTrail has audit information about how an EC2 instance was terminated, what API calls were made, from which location, by whom, using which AWS account, which IAM user account, for example. All of that information is stored in CloudTrail. It's an audit information. Okay, so it's monitoring all of your API calls. Okay, so next I want to take a look at question number 8. Which of the following are features of network access controllers? Select 2 answers. So sometimes you might get a question that is a multi-select question where you have 5 or even 6 sometimes answer options, and you need to select 2 or more answers. So here you need to select 2 answers for NACLs, features of NACLs. So this is one that you definitely need to remember. Okay, so you need to remember the difference between NACL, network access controllers, and security groups. Now with network access controllers, they're stateless, which means that you have to allow, or you have to configure the inbound rule and the corresponding outbound rule. And they support both allow and deny rules. Security groups do not support deny rules. They only support allow rules, and security groups are stateful. Those are the key variations and differences between the two that you must remember as a key difference between the two for the exam. Okay. So here we can see that there is an allow rule, allowing access from anywhere on the world, anywhere in the world on port 80, but we are subsequently denying traffic from this IP range on the same port. Okay. So what happens is when AWS goes through and looks at these rules, they'll look at rule number 50 and deny any traffic on port 80 from this range, but for the rest of the planet, it will allow inbound traffic on port 80. Okay, let's take a look at question number 9. So question number 9 is a developer needs to dynamically retrieve database credential information stored in AWS Secrets Manager. Okay. For an application running on an EC2 instance, which service is required by the EC2 instance to retrieve the credential data successfully? Okay. Okay. So let's just look at this question a little bit in detail. So basically, we're trying to retrieve database credential information from Secrets Manager. So just to recall, what is Secrets Manager? Secrets Manager can be used to store database credentials or secret information that you want to dynamically retrieve from your application. So you don't want to hard code database credentials in your application code in plain text. You don't want to be doing that. You want to be having the application retrieve those credentials dynamically when it needs it to authenticate against the database, right? So in this example, the question then is, which service is required by the EC2 instance to retrieve the credentials successfully? In other words, which service is required by EC2 instance to connect to S3, or so to connect to the Secrets Manager, to authenticate against the Secrets Manager, and to retrieve those credentials? Okay. So I'm just looking at some answer options. I've got some answer options for A by the looks of it, and A. And the actual answer is an IAM role. Okay. Now you can use access keys. Okay. And those access keys would need to give you permissions, obviously, to Secrets Manager. But an IAM role is a more secure method of configuring this required access. Okay. So with an IAM role, because an IAM role gives you temporary credentials, because an IAM role is not long-term credentials, it's a much more secure method than using access keys. Access keys are also stored in plain text on the EC2 instance, which is another concern from a security perspective. Okay, let's take a look at the last question, question number 10. So which AWS savings plans provides the maximum flexibility by applying discount pricing against EC2 instances, Lambda, and Fargate compute services? So here we're looking for the savings plan that you would recommend that provides maximum flexibility by applying discount pricing against EC2 instances, Lambda, and Fargate. So you want it across all compute services. Okay, so which savings plans would you go for? So you've got compute savings plan, serverless saving plan, SageMaker saving plan, and EC2 instance saving plan. So when you look at the savings plans that AWS offers, in fact, you will realize that there is no serverless saving plans. That's just a red herring over there. Okay, there are only 3 different savings plans. It's compute, SageMaker, and EC2. Now, EC2 savings plan is applicable only for EC2 instances, but we want EC2 instances, Lambda, and Fargate. And so the answer to that one is the compute savings plans. Okay, so when you look at the savings plans, the EC2 savings plans gives you the maximum level of discount, but unfortunately, it's only applicable to EC2 instances. Okay, but if you want to spread your savings plan across all compute services like Lambda and Fargate and EC2, then you're going to go with the compute savings plans. And obviously, SageMaker saving plan is applicable only for SageMaker services. Okay, so that is pretty much the end of that set of questions. I do have a huge bank of questions that is also available if you're interested. And this is where we pretty much come to the end of today's session. I hope you enjoyed this session. I hope you were able to benefit from this revision course. It is available on YouTube Live, so obviously you can go back and go over some of the content that we've covered today. If you are interested in obviously getting more questions, like I said, I've got 390 questions across 6 practice exams, where I give you full expert explanations along with revision links, references, and even some videos, very, very short videos that give you a breakup of what that service is. You can enroll on that particular web link, which is available again in the description box below as well. And if you use the education code the code education, you can get 20% off the market price. So that's just a quick special offer from us at the IAS Academy. And again, thank you very much for joining today's session. And I hope you benefited from this revision course and material. And I hope to see you next time. We'll call the session to the end now. Thank you. Bye.